Alright, on to jump scares. And what would a horror game be without a few jump scares, right? Good thing is, jump scares are actually relatively easy. It all depends on what you want to happen in the jump scare. So this video is basically showing you how to trigger them, because every jump scare is different. We'll also add one more type of jump scare after we add AI. So what we're going to do is I'm just going to make kind of a doorway. Should I do it this way? Sure. Alright, so I'm going to quickly make a little doorway out of this map real quick. Alright, so I switched to unlit mode really quick, and I've just made this pretty bad wall with a doorway in it, and then another room behind it. In game, you can see if I turn my flashlight on, it's big enough for us to fit through, and it is pretty creepy in here. So what we're going to do is essentially just add a trigger box, so when we walk into the doorway, an event is triggered where an AI will walk past the door and a jump scare noise will play. So pretty simple. So what we want to do is get a trigger box. So we can just search for it, box trigger. And this is the box that will activate the jump scare once we overlap it. So I'm just going to make it fit the entire doorway. That's good enough for me. And we just have to make sure you have the trigger box selected, and then go to blueprints, open level blueprint. And in the level blueprint, you can actually call a reference to whatever you have selected. So if I right click, you can see right here, create reference to trigger box. Let's go ahead and do that. And that'll work with pretty much anything you have selected in the world. Create reference to interaction outwards door. So what we're going to do is actually, we don't want just a reference, but we want to right click and we want to add event for trigger box 1, collision, add on actor begin overlap. So when our player overlaps this trigger box, this is called. And here we can do whatever we want for the jump scare. I'm going to be using a jump scare noise I found online called Low Reverb Hit by Christopher Patel on storyblocks.com. I do not own this sound, I just found it online that was allowed for use. So I'm going to create a folder called sounds and import it real quick. So I just went ahead and imported it, or hit low reverb impact. And whatever sound you use, if it's not this one, if it doesn't work when it's imported, check if it's an MP3, and if it is, convert it to a WAV file first, WAV. You can do this in Audacity if you have Audacity, or find an online converter. So the jump scare sound just sounds something like this. And what I'm going to do is create a sound cue. So if you right click, you can hit create cue. I'm just going to call this jump scare cue. And in a cue, we're not going to do anything with it, but you can create all different kinds of audio effects. I'm going to turn volume multiplier up to 1, or maybe 1.2, so it's just a bit louder. And I'm not going to go over what all these do, but it allows you to mess with your sound effects a little bit more. Another thing I want to point out before I go is I'm putting this to 1.2 because I've heard it and I know that's what sounds good, but it is important that you don't make your jump scare noise too loud. Blowing the audience's eardrums out will only make them more annoyed than immersed if you're really overplaying it, so just don't go too overboard with that. Alright, so let's go back to our level blueprint, and we can, on the trigger box, just play sound. And we have these options, play sound 2D and play sound at location. And if you play sound 2D, it'll just play it directly into your headphones. It's good for UI sounds, there's no attenuation. And if it's at a location, then it's actually in a spot in the world. And we don't need that, we can just have it play a 2D sound. And we're going to choose our jump scare cue. And you can also mess with the volume multiplier, pitch multiplier, etc. in here. And let's go ahead and just test to see if that works. And we can delete this because I don't think we'll be needing it. So when we overlap this trigger box, it's in the doorway, we should hear the jump scare noise. And we do. All right, so now we need something to happen, because it's a little disappointing if you just have a sound play and nothing else happen. So we need to import the UE4 mannequin, which comes with some of the UE4 templates, but we started on a blank slate, so it's not included with us, and we're just going to be using that mannequin for all the AI, since they already have some animations included, just to make it a little easier on ourselves. So we didn't import the mannequin with our project, so we have to create a new project and migrate the mannequin from that project to this project. You can do this with any project that you've already created with the mannequin if you want, but for our sakes, just for to keep it clean, I'll just make a new project for this. All right, and once that's all loaded in, we want this entire mannequin folder, because we have the character here, which includes the mesh, textures, and materials, and then we have the animations, which we also want. So if we go to Content, Mannequin, we can just right-click, and we want to hit Migrate, which moves the contents of this folder to a different game. And you can select specifically what you want. We're just going to go ahead and include all of it. And OK. And then you have to choose the correct location. So right now I'm in UE4 Projects Empty Third Person, which is the one we just created, content. So I'm going to go back to UE4 Projects. I'm going to find the one we're working on, Udemy Horror Game, and go to Content. And I just want to select this folder right here. Content migration completed successfully. All right, so now we're back in our project, and if you look right here, we now have this mannequin folder. Character, mesh, it's all there. Animations, it's all there. And that's exactly what we needed. So for our jump scare, I'm just gonna have the mannequin walking past as if it's some kind of enemy, and the jump scare is that the enemy is in the room. And I'm going to do this with an actor instead of making it some type of AI, because we'll be getting to that later. So I'm just going to make a new folder called Jump Scares, open it up, and Blueprint Class Actor, and I'm going to call this BP Doorway Jump Scare. So we need the mannequin in here, so I'm just going to add a skeletal mesh. Call it mannequin. For the skeleton mesh, choose SK mannequin. And for animation mode, instead of an animation blueprint, we're just going to use an asset. And animation to play will be walk. So it's just going to walk like this across the doorway. We also want to know where his endpoint is, so we're going to make an arrow. It's not going to be a child. We'll just call this endpoint. And let's just move it about 500 on the x-axis. And we're also going to rotate this mannequin 90 degrees, negative 90 degrees, so it's facing the right direction. So it's just going to walk from the starting point to the arrow. So something really simple just to demonstrate how to trigger this jump scare. And how we're going to do that is in the event graph, we're going to turn off inherited variables real quick. We're going to create a Boolean called jump scare, which will start off as false. So in the event tick, we're just going to ask if called jump scare is true, then we're just going to get the mannequin and set world location, and where we're setting it is going to be where the endpoint is, so we'll get world location, and if we were just to plug that into there, then it would just automatically snap to that location, and we want it to happen over time, so we will do this with a vinterp to constant. And the constant is so that it doesn't ease in and ease out of the 2 points. It'll go at a constant rate. So the endpoint world location is the target value. The current value is, the mannequin's world location. So get world location. Delta time can come from delta seconds in the event tick. And then the interp speed is going to be 300. It's just a value that I found works well. But you can also promote this to a variable, call it speed, and make it editable so you can easily change it in the engine. So let's just go ahead and place this in the world. I'm going to make it unlit so we can see a bit better. Take this, I'm going right by the doorway and rotate the whole actor 90 degrees. Our endpoint's right there. Definitely maybe a little too far, but we'll see how it looks. Actually, no, I'm going to move it just a bit closer for now. Something like 350. Okay, that's better. And we have to reopen the level blueprint. Make sure our actor is selected. And after playing the sound, we're just going to get a reference to the doorway jump scare actor. And we want to set that boolean to true. So set call jump scare to true. And then it will perform the movement. And then after 1 second, we're going to call a delay of 1 second. We want to destroy the trigger box right here so that we can't call the jump scare more than once. So select the trigger box. It turns out I was wrong. We do need this reference. And we'll just call destroy actor. Nope, wrong one. Destroy actor. There we go. And that's basically the gist of a jump scare. Let's go ahead and test it out. Oh. Let's move a bit farther back so we can't see him. And I'm going to go ahead and actually move this endpoint further out. I guess I was right in the long run. So let's make that back to 500. And let's try this one more time. So that worked, but we didn't get our sound that time. I'm not really sure why. Play sound 2D, jump scare, cue. Maybe I just turned my audio off. Right, so we actually did get the sound. My audio somehow got rerouted to a different speaker, so I didn't hear it through my headphones. Let's try it again. And I'm still not getting my audio. And there we have it. Honestly not exactly sure how that happened. But I'm just gonna get a wave player and select the sound again. Alright, well it works now. Save. Select my jump scare cue just in case. Nope, still selected. And let's hit play again. Test this for the 3rd time. And it works. Alright, don't really know how that happened, but you know, bugs come along the way, so you just gotta find your way around them. So that's our jump scare. It's basically the gist of a jump scare. They're incredibly simple. And you can do many things with it, such as maybe spawning in the actor when we hit a trigger box, so he's not always standing right here. Maybe disabling your character movement so we're unable to walk past it. List goes on. You can just do anything you want after overlapping this trigger box. But before we end the episode, let's talk about using jump scares correctly. Many bad horror games litter their game with way too many jump scares. It just becomes a game of predictability and loses story elements. So keep your jump scares, I wouldn't say few and far between, but be wary that you're not going overboard. I personally think when this happens, the jump scares hit a lot harder because you're your player is not constantly waiting for when the jump scare is going to happen. Horror games work better when they build up the suspense a lot, rather than just blowing up in your face every time you turn a corner. Alright, that's it for this episode. I'll see you in the next one. So the modern way to do footsteps in video games is with what are called, at least in Unreal Engine, animation notifies. You would call a notify to play a sound every time the foot of your character touches the ground in your character's animation. But this is a first-person game, and we aren't using animations, so we'll have to make a workaround, or essentially the way it's done when you have no character. So what we want to do is more than just play a footstep noise every time we're walking. We want to actually be able to change the footstep noise based on whatever material we're walking on. So to do that, we need to go to Project Settings, so Edit Project Settings, and we need to go to Physics, and we have to find Physical Surfaces, which is all the way down here. And we can create different surface types. We're only going to be working with 2 because if you know how to do 2 separate ones, you can add as many as you want. So we're going to do tile and grass. And we can go ahead and close that. If you want more, just keep adding them. So let's go to Content, and let's make a folder called Physical Materials. And we can open that up, and we have to create physical materials. So right-click, Physics, Physical Material, and we just choose this right here, and hit Select. And I'm just going to call this PM for Physical Material, Tile, and duplicate it, and call this one PM, Grass. So we'll open Tile, and there's a lot of options here, but the only thing we're worrying about right now is sound. So we just need to change the surface type to tile and grass, but they're not showing up. So let's try hitting save on everything. I'm gonna try closing it and reopening it. I'm gonna go back into the project settings, make sure they're still there. And that worked. So we can just go ahead and select tile, save, and then open grass, and select grass, and save. And that's the only things we need to do with those, so we can go ahead and close them. So let's just take our floors here, and we're just going to use these blocks that we have, and I'm going to make this one a tile ground. We should have a material because it comes with the starter content for tiles. And I'm just going to use this ceramic tile checkered. That looks good. And for this one, I'll use grass. And we gotta add, assign the physical materials. So if you, in the physics tab, we have, oh, not in the physics tab, I'm sorry, the collision tab, we have physical material override. And I'm just going to find our tile. And then for the grass, I will find grass. So now these materials have these physical materials assigned to them, but nothing will happen because we still don't have our sounds imported. So similar to the jump scare, I found some great concrete and grass footsteps. I found them on freesound.com. They are not mine, but I was allowed to use them. But these, the sounds I downloaded were a compilation of 6 sounds each. So I put them into Audacity and split them up to have 6 different footsteps. So if we go into sounds, I'm going to make a new folder called footsteps to organize it. I'm going to hit import, and I have all of these. So we have footsteps concrete, and then 01, 02, 03, 04, 05, 06. So I actually have 7 concrete ones and 7 grass ones. Oh wait, no, I'm sorry. We only have 6 of each because this first one is the compilation one. So I'm gonna just import these 12 files. And the reason I like having multiple of each is that so you can play them at random, so it won't be the exact same footstep sound every single time. So let's create a cue for the tile. So I'm gonna right click, go to sound cue, and I'm going to call this tile footstep cue, and open it up, and I'm going to add all 6 of these into the queue, just like that. And we have this random node right here, and we want to have 6 inputs. It's 5, 6, and we'll just go ahead and put these all in. So it'll randomly choose one of these every time the cue is played, and just plug it in like that. Now these are a bit quiet, so I'm also going to turn the volume multiplier up to 1.5. And I'm just going to do this exact same process for grass. So doing this process of having 6 different footstep sounds and playing them at random is not a mandatory step. You could just have one and just plug it into output like normal. But having the randomness definitely will make it sound a little better. But if you do only have one audio effect, if you made your own or you could only find one, you can add a modulator right here and put it through the modulator. And this will allow you to get a random pitch. So the pitch and the volume can kind of play at different random values within this minimum and this maximum, which is actually pretty nice. And on top of this randomness, I'm actually going to include the modulator for even more variety. And I'm just going to leave it at the default of 0.95 to 1.05 for both. Actually, I'm going to make this 1.45 to 1.55, and then just have this volume multiplier at 1. Doesn't really matter, it should give you the same result, I believe. I'm going to copy and paste this modulator to the tiles as well. Alright, so now we have our audio all set up, and I can press play over and over again to kind of create the footstep sound. And we kind of have this walking sound effect, which sounds really good. So let's go to our character and actually create the footstep sounds inside there. So let's go in here, and let's create a function called play footstep. And we want to check if our velocity is greater than 0, because we don't want to play the footstep when we're not moving. So we will, the character movement, get velocity, and then get the length, vector length, and let's just check if this is greater than 0. And you can also make it like, greater than 10 to just create a little buffer there in case you're moving so incredibly slowly you still don't think you should play footsteps. We also want to make sure we are not falling, because if we're falling, our velocity will be quite above 0, but we still don't want to play the sound, so we'll add an and boolean right there, and then we'll get is falling, which comes from character movement, and we will get a not boolean to make sure we are not falling. And we just need to call a line trace straight down to see what material we are on. So we can't use that line trace one we have right here, because that comes out of the camera, so we'll just have to make another one. So line trace by channel. And we're just going to get our location for start. So it's just going to start wherever we are. And it's going to end at our location plus a vector, which we split. And the z is going to be our location minus 100. So it'll just call a line trace to right below our actor, and it'll detect what material we are walking on. So we want to call an if statement for return. So only if it hits something will we continue off this true path. We can break the out hit result. And we have this node here called physical material, or physmat. And we can actually get the surface type, and we will use that to play our sound. So play sound 2D. This one we can actually play sound at location if we want, and play it where our actor is. So get actor location. But it doesn't matter too much. And for the sound we play, we will get a select node, and the sound we play will be based off our surface type. So we have a default, a tile, and a grass. So the tile will just search for tile footstep cue, and a grass, search for grass footstep cue. And we can also select default, so this is the one that will play if we have nothing, no physical material assigned, like this one right here. And we'll just set that to tile as well. And I'm thinking maybe actually instead of the actor location for the location, we can get the impact point. So it'll play it right on the ground rather than in the middle of our character, which is probably a smarter option. All right, so let's go into our event graph, and it's kind of a mess. We should probably organize this a bit with comments. But essentially on the begin play, we need to create a timeline. And we're going to call this footstep TL for timeline. And we want to make this 1 second long, and we need to add an event track. And we'll just call this footstep. So we can add a keyframe at time ½ second and value 1. And another keyframe at time 1 second and value 1. We can press these icons to kind of zoom into what we're looking at here. And now if we look at the event graph, we have this new output called footstep, and this path will be called every time we come across one of these keyframes. So we come across at ½ second and 1 second. And if we choose loop, this means every single ½ second this keyframe will be called. And we also want to select autoplay. And this is great, so we'll just play from start right in begin play. And off of footstep here, we can just call our play footstep function. And let's try this out. So let's go ahead and play. And we're walking on grass right now, so we should hear the grass footstep when we start walking, and when we get to the tile, it should start playing the tile footstep. So that sounds really, really good. We only have one issue right now, and that's if we start sprinting or crouching, it plays at the same rate, when it should be playing a lot slower. But while we're crouching, if we're sprinting, it should play faster. Oh, and also if we go on a material with no physical material, it'll still play the tile because we put that as our default. But we want to make it go faster when we're sprinting and slower when we're crouching. So if we go to our character and our input axis move forward, I'm going to just start commenting these out now because it's long overdue. So we're just going to call this movement. And we just need to adjust the timeline's play rate based off our movement. So, excuse me, I'm just going to move this to the left a bit and increase our comment size. And right before we get started, there's one thing we need to fix in headbob. Now that stuff is going to happen after it, we have to make sure the return is always called. So let's make a return node. Let's plug these both in, and we also want this function to return if we go off this false node right here. So now no matter what happens in this headbob function, this will continue. So creating this timeline will actually create a variable for us. So we have this footstep timeline right here. We can drag this out. Under the components tab, I should have mentioned. And what we're going to do is just call set play rate. And we're going to put this up here as well. And for the play rate, we need to get a map range unclamped. And our value is going to be our velocity. We can type get velocity and then get vector length and and this is going to output our speed, which if we go into movement, we can see right here. So our sprinting is 500, our walking is 250, and our crouch speed is 100. So the in-range A and B are going to be our crouch and walk speed. So if we get our movement, get crouch speed, and get walk speed, this gives us a range from 100 to 250. And for our walk speed, this will output our outrange B, so we want that to be 1, so it stays the same as what it's set to be. And if it's our crouch speed, I'm going to put it at 0.7, which will only play at 70% rate. And since this is unclamped, it means it will continue to do the math even if we go above our range B, which is our walk speed, which we will, because we'll be sprinting. So it can actually output a number greater than 1. So if we start sprinting, it'll do the math for us and start sprinting or playing it at a faster rate. Okay, so let's test out the timing right here. So if we're walking, it plays at a normal rate. And if we're crouching, it plays slower. And if we're sprinting, it plays faster. And that feels really good. And lastly, before we go, let's also change the volume so that when we're crouching, it's softer, and when we're sprinting, it's louder. So if we go back into our play footstep function right here, right where we play sound at location, we have this volume multiplier, and we're just going to use the same technique. So we're going to map range unclamped, and these values are going to be the same, so I'm going to go to the event graph and copy and paste the ones we just made. So our vector length is our value, crouch speed is in range A, walk speed is in range B, and it's going to be 0.5 for crouching and 1 for walking, which will make it a lot louder for sprinting. So we can test this out as well. So it should be normal when we walk. And then if we crouch, it should be half as quiet. And if we sprint, it should be louder. Right before we wrap this up, let's add this to jumping as well, because it should definitely make a noise when you land. Right now it's just silent. So if we go to L1 character, event graph, and create a our function on landed, or event, I mean, on landed, event on landed. This will call every time we land. And we just want to copy and paste everything in this play footstep after checking for this, because we don't have to worry about our velocity or is falling. So we're just going to Control C, and graph, Control V. Oh, that's a mess. Just going to start getting things out of the way. Oops, sorry, excuse me. And just gonna, there we go. Okay. And then unlanded, plug that in. Same line trace. We just check if we hit it. We check which sound to play. And I'm gonna get rid of this map range clamped. And we just want to make the volume multiplier 2. Just so it's a bit louder. When we jump. So let's try that. Yeah, that sounds great. So now we have our footsteps in place. And it works really well. It sounds really great. And that's it for this episode. I will see you in the next one. So a lot of horror games take the more cinematic route with cutscenes, and I personally think having cutscenes in your game really brings it to another level of professionalism, and they look really good when done right. So we'll use UE4's very powerful sequencer to do this. If you've been using UE4 for more than a couple of years, as of 2020, you might be a little more familiar with the Matinee which has been discontinued as of, I'm not actually sure which engine update discontinued them, but it is now the sequencer. So if we go to our content browser, make a new folder called sequences, we can create our sequences in here. So we'll make a new one by going up here to cinematics and pressing add level sequence, and we'll just choose our sequences folder. And I'm going to call this LS for level sequence enemy reveal, because we'll make it just revealing that an enemy is in the back room, something like that. And let's make another room in the back here to show that we are revealing our enemy. Alright, and we have another room. I'm actually going to put lights in this room so we can see, so I'm just going to grab some of these lights and bring them in there. Let's change this back to lit, and that looks good enough. So what I'm thinking what will happen to create this sequence is when we get to the doorway, it's going to start a cutscene, and let's just have a door open and our enemy be behind it. So let's search for door. We're just going to get the door frame right here. We don't need the actor. Let's get the door to go with it. Something real simple. And even though this is a see-through door, well, let's just go ahead and put our enemy behind it. So let's just go into mannequin animations, and let's just get the idle animation and put it right behind the door. So it's kind of funny because we will already very clearly be able to see that our enemy is behind this door, but this is just to show you how the cinematic will work. Oh, I wonder who's behind the door. That's hilarious. Okay, but let's get this sequence good and ready. Oh, this is not centered. There we go. Okay, so let's go to our sequencer here, and we want to create a camera. So we can click on this button right here, create a new camera, and set it as the current camera cut. And now we are controlling our camera, where it says pilot active right here. We are actually looking through the eyes of the sequenced camera right now, so we can place it the same way we just place our preview camera. And I don't actually prefer to do it this way. I'd rather move it myself. So I'm just going to hit this little eject button, and now we can see the camera right here, and we can move it like this, which is how I prefer. If you eject it but you want to go back into it, you can just right click and select pilot Cinec camera actor, and we're once again piloting it. We can also pin the view right here. So if I hit that pin button right there, I can select other things and this view will still stay here. And I like to do that while working with a sequence, so I always know what the camera's view is looking like. So what I'm gonna do is put this in its starting position. So I'm gonna set all the rotations back to 0, or I'll change the Z to 180. So first thing I'm gonna do, which is totally optional, is I'm gonna uncheck constrain aspect ratio. And what this is gonna do is keep the aspect ratio the same as your screen. If this is checked, it'll force it to be 16:9, which is what we have selected right here. And if your computer isn't that exactly, it will add black bars on the top and bottom to keep it at 16:9. I'm going to prefer it to not have that and just adapt to the size of our screen, so I'm going to uncheck it, but it's totally up to you. There isn't one that's necessarily better than the other. We can also do a few cool things like look at tracking settings, and if we enable this, it will always track where we want it to. And I want to track an actor. The actor I want to track is this idle animation right here. So if I click on this little eyedropper and choose the idle, our camera will always track the idle. See how it rotates when I move it around? If you look down there, it's always tracking the idle animation, which is the origin's at its feet, so it looks at its feet. But that's just something cool you can do. I might actually change this to the door. Door is also at its feet, never mind. So that's something cool you can do. I'm going to turn that off, but I am going to turn this on with the focus settings. So right now focus is manual and everything is in focus, but if we want to make it a bit more cinematic, I can change this to tracking and choose to track the idle third person idle right here, and that'll track the depth of field so that the character will always be in focus. Or I think it might actually be smarter to do the door, so I'll track it to the door. Anyway, I won't spend too much longer going over all these settings you can change. Let's go over to how to actually make this cutscene. So I'm gonna reset this rotation, which got a bit messed up while tracking the animation. And what we can do is turn on automatic keyframes. So once automatic keyframes is turned on, everything we do in terms of moving the camera will be recorded. So you gotta be careful with it, but it also makes it easier than just constantly hitting the keyframe button. So it is up to you. So let's put it in its starting position, and let's turn on automatic keyframes with this button right here. So now that it's selected, it'll create a keyframe every time something is changed. So I'm gonna get it into its starting position. I'm gonna aim it at the door, and then I'm gonna kind of rotate it down, bring it maybe a bit closer, and let's add our first key manually under camera component transform. If transform isn't there, you can under camera component you can hit track transform and it should come up. Then I'm going to go ahead a few seconds, maybe at 90 frames, and I'm going to bring it up to the door and rotate it up maybe a bit closer. Okay, that looks good, and we can see kind of the line happening here of our track. And then at this 3-second mark, I think, we wait just a little bit and the door should swing open. So we have our door right here, and if the door is not showing up, then you can just select it, right click, actor to sequencer, and the selected actor should show up. I'll select something else to show you. Actor to sequencer, add floor 20, and then it'll pop up. And we're going to go ahead and delete that, and I'm going to delete the third person idle because we don't need that either. So once we got our door, we want to track its transform as well. We're only going to be tracking its rotation, so let's create a keyframe for rotation right here, and go ahead a couple frames and rotate it 90 degrees. And since we have automatic keyframes turned on, it automatically creates a frame right there. You have to create your own keyframe first, or else it won't record. So the first one has to be manual. Just want to be clear about that. So now I'm going to click here again. I'm going to pin this again because it became unpinned. And if we just scroll through and we just watch the little preview up there, it goes in, and then the door swings open to reveal, well, quote unquote reveal our character. Then we don't want it. We don't want it to just stand here for this long, so I'm going to go ahead a few frames, and I want it to end right here on 125, so I'm just going to drag this down here to 125, and we have our sequence. If you click on these playback options, you can also set it right here and choose the playback speed, and we can also just play it just to test it in full time. Great, it's good enough. We can add more things like a fade track. So if you click track, you have these options. You can choose fade track like this. Maybe we want it to start at like 116. So we will add a keyframe with it at 0, and then to 125, we will increase this up to 1, which puts it to black. And if we want to see it in action, we can hit render this movie if we want to output it like that, but I'm not going to do that right now. If you want to add stuff like audio, you would just add an audio track right here. But I'm gonna cut short on all the things we can do in this sequence here and show you how to actually implement it into the world. So if we go back into the content browser, sequences, we have this sequence now. And we're going to duplicate this trigger box. We're just going to have it work the same way as the jump scare, where it triggers when you overlap this box. So when you get to the middle of this room, it'll do it. So if we go to our level 1 blueprint, blueprints, open level blueprint, and we can just right click, add event, collision, add on actor begin overlap of the trigger box 2. We will create a level sequence player, and the level sequence we want to play is the enemy reveal, which is the only one we have. And if you want to mess with the settings, we can make, and then we have things like looping, play rate, start offset, random start time, etc. And we actually do want to do a couple of these. For example, you can hide player, which if we had a player mesh, it would be hidden. It's good to just have that in general so our camera doesn't overlap with it. We can hide the HUD as well, which will get rid of our HUD when we play. And we could pause at the end, but we're not going to do that. We can also disable our movement and our look input, which we do want. And I think those are all the things we want to do right there. All right, after that, we want to actually play the level sequence, because similar to widgets, just creating it will not play it. So let's hit, we're out of return value, we'll hit play. And after we play it, we want to get a reference to the trigger box and destroy it. So that we can't call the cinematic more than once. So let's test this out. Where are we? Everything is completely dark. I don't know why. Oh, everything was completely dark because in the sequencer, I had this way at the end of the fade track, which we don't want. And we still had the record button on, the trigger box was added, and so was keyframes for its transform. So we don't want that, so we will delete it. We will uncheck this. It's a good lesson to learn. I still make that mistake all the time. And that's why this option is a little dangerous, because it'll record everything. But yes, and then we will save it. So we can just go ahead and close the sequencer now, hit play, and we should be good to go. So first we'll get hit with the jump scare, right? And now when we go across the trigger box, which we can't see, in the middle, oh, flashlight ran out, the sequence should start. And there we go. Our sequence played. We once again have control of our character. And you'll notice a couple problems. One, the HUD did not actually go away, despite us choosing the hide HUD button. And two, the door opened, but then the sequence ended and the door is now shut again. So we gotta fix these things. So if we open up our sequence again and open up our door, go to transform and right click in this path right here, go to properties, and we have to choose when finished, keep state. You can do this for anything in the sequencer. For the fade example, if we kept the state, it would stay dark, like completely black after we were done, which is something we don't want. We could keep the state of the camera actor, which would keep it in this position, but it doesn't matter because we won't be viewing it again. And lastly is the door, which we are keeping the state. So now if we hit save, and we try it again, we'll get jump scared first, right? And then the sequencer starts, the door opens, it fades out, and the door stays open, which is great. Now, lastly is that the HUD still stays on the screen. Sadly, we will have to do it manually. So what we can do is after we play, but before we destroy the actor, we'll have to hide the HUD from the character. And we have to cast to the character to get that. But let's do this in the beginning. So cast to L1 character. And the reason we're doing this in the beginning is we can set the object to other actor on actor begin overlap. So not only does it take it from the overlapped actor, but taking it from this path guarantees that everything after this will only be called as long as only the actor overlaps with the trigger box. We could do the same with the first trigger box that we do for the jump scare. Cast to L1 character. And that way, if there's any type of physics objects that rolls to the trigger box, it won't be triggered. It'll only trigger if our character goes through it. So, as L1 character, we will just get the main HUD ref and set visibility to hidden. And then we will wait the duration of our sequence. So out of the create level sequence player, we can get duration, and we want to get the frame duration. So it outputs in frames, and we can convert that to seconds, which is what our delays counted in. And we could figure this out by opening our sequence, checking the frames per second. We have it set to 30 frames per second. So it's 125 frames. So we can just get an integer, the amount of frames divided by our frames per second. So just get a float, make literal float right here, 30 frames per second. So we'll get the number divided by 30, and that should give us the length. So once that's completed, we'll get our main HUD ref, and we'll set the visibility back to non-hit testable, self-only. So we can test that out by hitting play, getting jump scared, just walking past it, and let's test this out. So let's watch our HUD. Goes away when it starts, plays, and it ends, and our HUD comes back. So perfect. That is how you create a cutscene in a game. There's, the sequencer in Unreal Engine is very advanced, and that's just only the beginning of what it can do. But this episode's getting a little long, so we're going to cut it off there, and hopefully that gets you started on cutscenes. I'll see you in the next episode. So let's work on objectives. Objectives are going to be stored inside our game state. So if you go into your game BP folder, and in level 1, we have our game state right here, which I explained in an earlier episode. You can hit open full blueprint editor in case this does not come up. And the first thing we're going to do is create a struct for our objectives. So let's go back into content, blueprints, structs, and let's right click, blueprints, structure, and we will call this S, objective data. So each objective is going to have some data, such as a name, a title, whether it's completed or not, and I believe those are the only 3 we are going to have. So let's make those. So first we want to have an ID name, so do ID name. Oh, and that's going to be of type name. We're going to have a title, so we'll call this objective title, and this will be text. And we need objective completed, and this will be a Boolean. Alright, so let's go back into our game state, and let's create an array of the struct objective data. So make a new variable, and we'll call this, let's just call it objectives, and it's of type S objective data, and we want to make it an array. And here you can add as many objectives as you like. And you want to keep them in the same order as you want them to work. So for this first one, we can be telling the player to pick up a battery. So the ID name, so we can access it, can be pick up battery. And then the title is what's going to actually be displayed on the screen. So we could just make that pick up a battery, or maybe find battery, doesn't matter. And objective completed, we want to leave it to false for all of them by default. After that, the next objective can be use battery, and the title can just be use the battery. And lastly, we'll have one that'll say investigate noise. And the title will be investigate the noise, not the nose. All right. So now we have our 3 objectives to beat this game. And we need a way to display this title here so that we can actually know what our objective is. So we'll need to do that with a widget. So if we go over to UMG, we can create a new widget blueprint, and we'll call this W objectives. And I'm just going to make something really quick. I'm just going to drag in a text. I'm going to anchor it. Yeah, top left is fine. Just put objective title goes here. Let's wrap it with a size box. So wrap with size box, and this will put it inside a size box. And this way we can decide how wide it is. So let's say something like 600, and y can be like 150, just for safety. And I'm gonna just put it, oops, something like here. And the reason I put it in a size box is so we can wrap the text. So if the text gets too long, this is where the objective text goes. We want to be able to wrap it so it doesn't just start filling up the entire screen. So if we scroll down and select auto wrap text, it'll automatically detect that. I'm also just going to make it our font here. Maybe size 20 is fine. Maybe give it a shadow, just so we can see it a bit better. And that's good enough. So let's make the text a variable, and we'll call it objective text, so we can alter it later. And in the graph, we will make a custom event called update objective text. And we'll just get the objective text, set text, and the in-text can be part of this as an input right here. Now we'll just, yeah, in-text is fine. All right, so let's add this to our main HUD, and I'm actually going to get rid of the default text. Well, I'll wait till we get it on the main HUD to make sure it looks good. So open our main HUD, objectives, we'll just pull this in. We want to anchor it to full. Since I just left the canvas panel in here, we're just going to anchor it to full and put all the offsets at 0, so it'll be in the same spot. And that looks good. And we can even see what it looks like in game, and that's good enough for me. So now I'm going to get rid of the default text so that nothing appears when we start playing. All right, so let's go back to our game state, and let's create a function, and we're going to call this find current objective. And essentially what this is doing is when we want to start an objective, we have to find it using the ID name, and we want to say start this objective right here. So it's just we're gonna create a for loop from the objectives array. So for each loop with break, and we're just gonna break this array element here to get all the objective data, and we're just asking if the objective is completed. And if true, we want nothing to happen. But if it's false, that means that's the next objective in our list that we need to trigger. So if it's false, we will break this. And actually right before we break it, we want to set this array element as a local variable. So promote to local variable, we'll call this local objective. So it knows that this is the objective we want. Then we'll break it. And then once it's completed, we will call a return node with the local objective as an output. We'll just call this found objective. All right, and then we also can make this function pure because we don't need to run it through an execution node. All right, next we need a reference to our main HUD so that we know to update the objective text. So we're going to make another function called initialize, and it will have an input of the main HUD. We'll just call this main HUD, and let's create promote that to a variable. Call this main HUD ref. And we need one more function that sets the objective. As this one only finds it, we need to actually set it. So we will create a function called set objective, and in here we will find the objective we are trying to set. And what we want to do is take the main HUD ref and update the text in wObjectives. So we will get wObjectives, and then we will call this custom event update objective text. And the text we want to display will come from the found objective. So we will split this, and we want to take the title and plug it into the in text. After that, let's set the visibility of wObjectives to non-hit testable, self-only. Because in between objectives, when we don't want to display anything, we'll set it to hidden. So we want to make sure we set it back to visible once the objective is set. We also want to be able to complete objectives, so we will need another function for that. We'll call it complete objective. And we want to get the find current objective function because we want to set the current objective to completed. So we'll get this objectives variable, and we will call what's called a find item. And the item we want to find is the current objective. And then we just want to set the array element at this index. So we'll get a set array element at this index where the current objective is. And we can split the item. Actually, instead of splitting, to make it a bit more clear, we'll call a make, which is essentially the exact same thing. And we want to keep the name and title the same, so we will break it from the current objective and just take it from there. But this time we want to mark the objective completed to true. After that, we want to set the objective widget to hidden. So we'll get it, no, not the objectives. We want the main HUD ref, wObjectives, which is our widget, not set, I'm sorry, wObjectives, and we will set visibility to hidden. So compile and save, or we can actually also add a return node, compile and save, and then in set objective, let's add a return node. It's good practice to always have a return node at the end of your function, something that I am still not in the habit of for who knows why. But in our initialize function, we want to call set objective so that it's called right at the beginning. Now let's go to our character. So GamePP, level 1, L1 character, and in our begin play, we're in our event graph here. In our begin play, we want to go to our initialize function and add a pin to the sequence, cast to our game state, which is called L1 game state. For the object, it'll just be get game state. And then as L1 game state, we want to call the initialize from the game state. So initialize, and it asks for the main HUD, which we have a variable of in our player, so we will just take it from there. Go out and save. Great, so now when we hit play, our L1 character will cast to the game state and call the initialize function, which in the game state will call set objective, which will update the objective text in WObjectives and set the visibility to true. So when we hit play, it should activate the first objective, which says find up a battery. I didn't even realize I typed that. We just want find a battery. And let's go ahead and hit play. And there it is. It says find a battery. That's great. Now if we go pick up a battery, we're back here, nothing will happen because we have no way to set the objective to be completed. So let's go ahead and do that. And we're going to do this with a blueprint interface. So let's go back to content, blueprints, interfaces. Let's create our third one. So right click, blueprints, and blueprint interface, and we'll call this BPI objective call. And we can open it up, and we're going to call this function complete objective call, and it's going to have one input of type objective ID, and this is where that ID name comes into play, so we know which objective to mark as completed. So make it of type name, and we actually need a second input, and this will be called set next objective immediately, and this is a boolean, and this is essentially asking, as soon as this objective is completed, do we want to move to the next objective on the list, or is something else in the world going to activate it? So we can compile and save and close that. So the first time we want to complete an objective is when we pick up a battery, right here. But before we open up our battery, there's one thing we need to change. So let's go into our blueprints, actors, and inventory, pickup actors, pickup actors, and pickup actor master. And essentially what we need to do is right here where it says input action. Oh, seemed to have froze there for a second. We actually need this whole section to be a function because we need an output now. So just select everything that happens after input action, right click, and collapse to function. And we will call this pick up item because that's what we're doing. You can open it up. And we just need a return node with a boolean called success. And we can copy and paste this return node to the 3 different spots where the path can go down. And let's see where it needs to be true. So it's been a while since we've been here, or at least since I've been here. So we add the item. If we successfully add the item, yes, so that is a success. This is still a success, and this is not a success. Now we can open the flashlight battery pickup actor, go to open full blueprint editor, and this follows all of its parents functions, which we have in here. And we need to override the pickup item function, the one we just created. So go to functions, override, and pickup item. That's the one we just created. So now we have a function called pickup item, which calls the parent function pickup item with the outputs. So if we were to do nothing right now, not a single thing would work differently, other than we just created an unnecessary step. But we need to know if this was successful or not in order to call this objective. So if this was successful, we want to get our game state and call, I'm already forgetting what we called it, let me go check. Complete objective call, okay. Call complete objective call message, so off true. And we need to know the objective ID. So we need to enter this manually, so the best option here is to go to L1 game state and copy and paste. So ID name is pickup battery, so I'm going to copy and paste. And then we want to ask, do we want to set the next objective immediately, or do we want to trigger it somewhere else in the world? And the next objective is use battery. So I do want to call this immediately. So as soon as you pick it up, your next objective is to use the battery. So I'm going to check that as yes. And now let's get this return node off here. And then if it's false, we want to make sure we still have a return node like that. So let's go back to L1 game state, and we need to actually add the interface to our game state. So if we go to class settings right here, implemented interface, we can add BPI objective call. So now, if we open up interfaces, this is now here, complete objective call. If we right click, we can hit implement function. So now every time complete objective call is called, for example, in the flashlight battery, it's called right here, this will be triggered. So we will get our find current objective function, and we just want to check if the objective ID is equal to our current objective ID name. So that it will only complete the objective if it's the objective we're currently on. Now if we want to set the next objective immediately, then we will call set objective, or sorry, not right off that true, but we want to call another if statement, and then call set objective off of true of that. Alright, so let's test this out. So what should happen when we play is once we pick up the battery, assuming it successfully adds to our inventory, our complete objective call will be called for pickup battery, and that will complete our objective, which I just realized I forgot to actually add in here. So let's pull that out. If it does equal, and if this is true, we want to call complete objective. That would have been a funny thing to miss. And then it asks, do we want to set the next objective immediately? Which we do. So once that objective is completed, it should immediately switch to the second objective, which is use the battery. So let's test that out. So let's hit play. It says find a battery in the upper left. Let's pick up this battery, and once I do, it should say use the battery. There we go. Our new objective now is to use the battery. Now if we do use the battery, nothing will happen because one, we don't need to use the battery since we have full battery, but two, we do not call the objective call from there. So let's go ahead and throw that in. So when we use the battery, that's called in our item blueprints actors inventory, and then BP inventory item flashlight battery. We can open this up, and we have this event use item. If the use item was successful off this true path here, we can get the game state and call objective complete. The objective ID is going to be use battery, so I'm going to copy and paste it. And set next objective immediately, I do not want to check at this time because the next one is investigate the noise when no noise has played. So this time it's not going to do anything or other than remove the current objective. Or actually we need to make it do that. So let's go back to L1 game state. Assuming the objective ID equals the current objective name, we complete the objective. And if we don't set the next objective immediately, then nothing will happen because incomplete objective, we set it to hidden. So let's test this out one more time. So find a battery. Why, there's a battery. Let me go ahead and pick it up. Now it says use the battery. And let's use a bit of our flashlight so we actually can. Let's hit use, and our objective just goes away because we completed use the battery, but no noise has played and nothing's telling us to investigate the noise. So lastly, let's call a new objective when we want to in the world. And I'm going to do it for our jump scare here, since it makes a noise. So once we go through this trigger box, but for this we need a new function in our blueprint interface objective call, because right now we only have complete objective call. So let's add a new function, and we will call this set next objective. And if you want, you can actually create an input for the objective ID to set a specific objective. So call that name, compile and save that. And I don't think we'll need this again, so we can close it. And if you remember, in our trigger box, we set it in the level blueprint. So if you go to blueprints, open level blueprint, it's right in here. And it's this first trigger box up here. So we play the sound, we called the jump scare, we delay, we destroy the actor, and we want to get our game state and call that second function we made, set next objective. And let's set the objective ID name to investigate noise, copy, paste, and then in L1 game state, we can call this set next objective function, or implemented I mean, and we will just call set objective. But we want to make sure the objective ID equals to our next objective ID, which is an optional step. You can flip this to have the objective ID be an input for set objective, and then set objective goes through our array here and searches for the correct objective to call. It's totally up to you. But for now, we're just going to do it like this. Find current objective, split, and just make sure the ID name is the same as the one that's next. And let's go ahead and test that out. So when we hit play, we can go get this battery. Now it tells us to use the battery. We will hit use. Oh, not successful because our flashlight is full. Let's try it again. Now that goes away. Let's go trigger the jump scare. And now it says investigate the noise. Where's the noise? Oh, it's right there because I forgot to destroy this actor. Anyway, that is how you get started on creating objectives for your game. There's a lot more you can do with it and a lot of different ways to go about it, since many games do it differently, but hopefully that puts you on the right path to getting it perfect for your game. I will see you in the next episode. Sometimes it's cool to peek around corners with a lean, and we're going to do that in this episode. We're going to use the Q and E keys to lean, but if you'll notice in our L1 character, we already use the E key to interact with certain objects. If we see our input action, this is the E key. Now what could be an easy fix is you could just definitely go into the settings and change this to, say, the F key, which is something most do. but we're going to find a bit more of an advanced workaround just in case you don't want to do that, even though it might be the smarter option for most games. So essentially what we're going to do is after this line trace, we're just going to check if it hits anything, and if it doesn't, then we'll lean. But if it does hit something, then we will ignore the lean and continue with the interaction. You can definitely just easily just make them different keys. It is totally up to you. So off this false here, we just want to call a timeline. We're going to call this lean right TL for timeline. Actually, what I think I'm going to do is actually make a custom event for it. Just call this lean, and I will put the timeline here, and instead just call the custom event. And break that right there. Okay, it's a bit cleaner. And we're just using a timeline here to control the camera, to just tilt it and move it a little bit to the right so we can double click to open it up. I'm just gonna start closing these. Create a float track, we'll call it alpha. I'm gonna make it take 0.3 seconds to lean. Add 2 keys. I'm going a little fast here because we've done quite a few timelines, and you can see the pattern that I take with them. So make the first one at 0, time at 0, time 0.3, value 1, scale to fit. Gonna change this to auto, compile and save. Alright, so we're just gonna get the player controller, get control rotation, and set control rotation, or I have to pull that out of here, set control rotation. And we can just split both of these because we only have to mess with the X rotation, the Y and the Z will stay the same. And then the X is going to be a lerp, or linear interpolate, with the alpha as alpha, and the A will be 0 because that's the default, and we're gonna rotate it 20 degrees. We can actually go ahead and test that. So as long as we hit E and we don't interact with anything, the camera rotates 20 degrees, and we are stuck like this. But I also feel like it doesn't go out quite enough. I mean, if you like it like this, then perfect, then you have to do less work. But I'm also going to move the camera a bit to the right, just so it's a little easier to peek around doorways and such. So we're going to get our camera, get relative location, set relative location. Once again, split these. Y and Z will be the same, and then X will once again be lerped, with this as the alpha. Oh, I'm sorry, I just realized we're not moving it on the x-axis, but we are moving it on the y-axis. So X will go to X, and then Y will go to the lerp. And the starting position will be the camera's Y value, and the ending position will be Y plus an amount you want it to move to the right. I found 2 to be a good amount, not too much. And you can definitely make this into a variable if you'd like. And just, I'll do it, why not? Lean amount. Something like that. And compile and save. And I'm just going to comment this out as lean. And this as interact. I should have been doing this since the beginning because I can very easily get lost in this mumbo jumbo we have right here. But won't keep wasting your time on commenting. Let's get back to it. So now, yeah, we should be set up to move the camera a bit to the right as well when we press E. So yeah, it does not go back. but you can definitely see that'll help with doorways. So let's trigger this jump scare real quick. Yeah. And if we want to peek around, that works really well. And let's just make it so we can go back once we lean, because our character does not have a crick in their neck. So once we release our action key, which is E, we are going to call another custom event, unlean. Let's actually, we're gonna have to call these lean right, and then unlean right. I don't know if unlean is a word, but I don't care that much. So let's put that to reverse, and then once we go over E key, we will call unlean right. So now, when we play, if we hold down E, we're leaning, and if we release it, we go back. Not quite. We are actually moved even more to the right, so we can just keep moving right forever. Kind of looks like we're dancing. Alright, let's fix that. And I've realized the problem. It's because on this lerp here, we set the starting position to wherever the camera currently is, and when we release it, it resets this to camera being farther to the right, so it just moves closer to the right. So instead of the camera's current Y position, it's just going to be 0. So now when we hit play, we hit E, it moves the camera 2 units to the right, and we release it, it goes back to 0. There we go. And now we just have to copy and paste everything to lean left. So let's just bring this down. Let's Control-C, Control-V. And I'll call this custom event lean left. This custom event unlean left. The timeline will be called lean left TL. Let's compile to get rid of the errors. The lerp, instead of rotating at 20 degrees, we want to rotate at negative 20 degrees. And we want to multiply this lean amount by -1, so it goes in the opposite direction. Now when we hit Q, which I don't think is set up as an input, so let's go to Edit, Project Settings, Input. We'll just call this lean left for now, because I don't know what else Q would be mapped to. Input action lean left. On pressed, we will just call lean left, and on released, we will call unlean left. So let's test it out. Hit play. If we hold down E, we lean to the right. If we hold down Q, we lean to the left. Now, you'll notice one small issue, which I actually am just noticing right now, is if you hold down E and then you hold down Q, it kind of snaps to the position. Everything gets a little wonky because it's trying to do both at once. So we're just going to have to add a boolean called isLeaning. It's false by default. And then when we start leaning, if we hold lean right, then we will set isLeaning to true. And then if we're unleaning right, we want to set it to false once it's finished. So off of finished here, or off of direction, we're going to call a switch on E timeline direction and connected to finish. So once it's done, if we were reversing, so if we were unleaning, then we will set isLeaning back to false. So once we're done leaning, isLeaning is set back to false. All right, so let's copy and paste that to lean left. Okay, right there. And then this same thing right here, copy, pulling these guys down once again, pulling this down, paste, direction in there, that to finished, and isLeaning left. And lastly, We can only call lean left if is leaning is not true. And this goes the same for lean right. We all love the power of Booleans. All right, hopefully I've done that all correctly. And if we hit play, lean right, I'm holding down Q. Oh, okay, so I see our issue is holding down Q will do nothing, but releasing Q snaps this back to normal. So I'm realizing we will have to actually make two Booleans. Sorry, this is a little messy here at the end. I didn't encounter this bug the first time, and I'm just making up the solution on the fly. So bear with me. So we need an is leaning left and is leaning right Boolean. So we have our is leaning right here, and essentially what we want is we want to make sure we are both not leaning right or left. So and not leaning right and not leaning left. Perfect. And then we set is leaning right to true, and then off of unlean right, we want to check if is not leaning left. And then after we finish, we set is leaning right back to false. Now we'll do the same on lean left, except we'll reverse it. So we can go ahead and grab is leaning left and not, because this will be the same here. So we're checking if we're both not leaning left or right to lean at all. And then we want to set is leaning left, not is leaning right. And then unlean left, we'll check if we are not leaning right. And then once it is finished, we are set is leaning left to false. All right, hopefully that will work. Let's hit play. I hold down E, I'm leaning right. I hold down Q, nothing happens. I release Q, nothing happens. I release E, we go back to normal. And the same works on the left side. There we go. We are now bug free and we can lean either way. All right, looks like no jump scares are in there. Oh. All right, that'll be at the end of that episode. Once again, I apologize for getting a little messy there, but we got it figured out together, and it is all working now. I will see you in the next one. I want to go over the process of making a good level that's more than just this conglomeration of actors inside a couple of boxes. Now that we have a good amount of our horror mechanics set up, I want to create an actual scene where this can play out kind of the way an actual game will play. The assets I'm going to be using are from UE4's Sequencer project, which you can use too, although I advise that you find your own assets. So if you open Epic Games and you go to the Learn tab under Unreal Engine, and you scroll down near the bottom, I believe, right here, the Sequencer project, you can open this up and actually create a project from it. And if you look, this is just a project to give you an idea of how the sequencer works, so if you want it for that, then that's perfect as well. But you can see we kind of have this Subway asset pack included with it, and that is what I'm going to use to create our scene. So you can just hit Create Project, and I've already created mine, so I'm just going to open it up. And once that's open, I'm just going to let all of these shaders compile as it waits, and I'm going to go to Content, and we have this folder here called Assets, which includes our meshes and materials and a few other things. So once the shaders are finished compiling, I'm going to migrate this over to our project. Okay, so the shaders are done compiling, so I'm just going to right click on Assets. We're going to hit Migrate, and you can uncheck anything you don't want, but we're just going to be moving all of it for now. Hit OK, and we want to find the project we're looking for. So I'm going to go to my UE4 projects folder, find our Udemy horror game, and go to content, and then you can just put it here in content. Select folder, and it'll copy all the files over. Once you're done, it should say content migration completed successfully, and you can close the sequencer project. Back into our other project, you'll be able to see now that we have this folder called assets, which is perfect. So I'm going to make a new scene for this. So let's go to maps, right click, level, and I'm going to call this horror level. I'm going to open it up, hit save, and it's completely dark. There's absolutely nothing in here. So before anything, if you remember way back from one of our first episodes, we're going to add a post-process volume. And we're just going to turn the exposure min and max to 1 so it doesn't mess with our exposure. We also want to go to the world settings and choose the game mode override to our L1 game mode, which is the game mode we created at the beginning, which has our character and player controller and everything we need. So I'm just going to throw together a level real quick that I'm going to speed through, because this is just going to be me dragging and dropping assets that you can do in whatever fashion you want, or you can copy mine. It doesn't matter. Right before we get started, though, I want to point out one thing. In the assets mesh, if we search for floor, we have these two floors here, hallway floor 600 and hallway floor 600 simple. You're going to want to use the simple one because the hallway floor 600 has been subdivided, so it has nearly 400 faces, whereas this floor only has one. If I drag it in, we're in unlit. If I drag both in, you'll see that they look the same. Well, that one's a lot lower, so it looks smaller. But you're going to want to use this one because the other one has been subdivided to accommodate for painting and puddles. But the simple one also currently doesn't have a collision, so let's open it up. If we go to collision, simple collision, nothing pops up, so we just have to go to collision, add box simplified collision, and it should add it with the correct dimensions. And then you can close it again. Oh, one more thing, I'm going to reopen it up. I'm just going to change the material from this from gray to floor water mesh paint instance, just because I think that looks a little better for what I want as a floor. And I think I'm going to double the size of the floor since I don't need the tiles that small. Perfect. For the ceilings, I'm going to be using the floor mesh as well. Just turned upside down. And the material I'm going to be using is going to be ceiling mesh paint inst. And lastly, before I start the time lapse of me making a level, for the stairs, I'm going to scale them at 1.5 instead of 1. Oh, sorry, I meant to only scale them 1.5 on the z-axis. There we go. All right, now I'm going to time lapse of me just creating a quick level. Alright, so I have completely built my scene here. It's fairly simple. I added a little more than the areas you'll actually be able to go. It's just this room, upstairs, this room, and this room. And I added a door, the one that we made early on. And sadly they didn't really have a doorway asset, so I just had to kind of improvise and create my own, but I think it looks alright. I added in some lights, but these do not actually emit any light right now. If we go to lit mode, it's completely dark. They are emissive, but they don't emit light. Like they don't contribute to the static lighting in the scene. These are just two, and I just added some details. We'll be actually lighting the scene in the next episode. So once you've created your scene, you can just go ahead and go to the next episode. I'll see you there. Alright, so let's start lighting this level, because right now when we hit play, we cannot see a thing. Since we never have an exterior, we have no need for a directional light or anything in that sense. I'm just going to grab all these things real quick and create a folder and just call this geometry, just to put it all inside there. So we don't have to worry about any type of exterior light, which is really nice. So if we go to lit mode, you'll see that it's completely black right now except for the lights, because they have an emissive material. First thing we want to do is create a light mass importance volume. So in classes, just search for light mass. We'll take this light mass importance volume right here. And I'm just going to go into top view, make it unlit. And we can just scale this up to enclose our entire scene. This kind of tells the engine where the lighting is most important, so it's better than having it try to do it everywhere. So just enclose the scene, go back into perspective, and that's all we need to do with that. I'm going to put it into a new folder called lighting, and I'm going to put the post-process volume in a folder called rendering. And this is door, can go in geometry. So how I think we should light the scene is just with some spotlights coming from all of these lighting assets. So for example, let's just get one light in here by going to lights and spotlight. And let's just kind of position it on this for now. Alright, that looks good. And if we go into lit mode already, you can see this creates a spotlight. And we are getting this exposure, and that's because I forgot one step, something that I talked about for quite a while when we first did the post-process, is I forgot to set this to unbound in the post-process. Now our lighting exposure is set to 1 at all times, and we have a perfectly clear view of what our lighting will look like. So we're going to change this source radius, which is the radius of the light source shape, and we're going to change it to something like 9. Oh, I'm going way too high on that. To kind of get the width of these 2 bars of light right here. And let's get this source length and extend it. We can see it's extending the wrong way, so we're going to rotate this 90 degrees. And I'm just going to extend it so it's about the length of our light right there. So about 100 works. Let's also make sure the light source is just slightly below the light itself so that it doesn't cast shadows, but I think it was fine where it was, but you know, can't be too careful. So next, what we want to do is take this outer cone angle, and this is just the cone of light. So you can see how it gets smaller and bigger with this. And I want to make this real wide, so something like 75. Since this is going to be our main sources of light, I'm just going to have these cover a pretty wide area. We can also adjust an inner cone, which kind of tells us where the fall off, where it gets from lighter to darker, should start. So everything in the inner cone is going to be at full brightness. So you can see if we put it all the way up, it's a very sharp line because it has no more fall off. And we don't want that because that doesn't look natural. But we can make it something relatively small, like 10 or 20. I'll just go ahead and go with 20. And even though it is a little dark at the moment, I'm actually going to turn the intensity down to about 4. Just because when we get all of the lights in, I think it'll be a bit more lit up. And I believe I mentioned this earlier, but a great balance you want to find when lighting a horror game, while most horror games are going to be dark, you want to make sure it's not impossible to see. It's another mistake I see across a lot of indie games. Sometimes it is just way too dark, and it is impossible to play without the flashlight. And I'm still a strong believer that the flashlight should not be a 100% necessity for seeing in your game unless your game revolves around the flashlight. So you want to find that balance of you want to be able to see without the flashlight, but you want the flashlight to feel useful. So when it's this dark, I can still see in this section for sure, but if I have this flashlight, it makes it a lot easier. So you want to really just mess around with the intensity and find that balance. But I think it's good to mess with intensity once you put all the lights in so you can kind of see how the whole scene lights up. So let's go to world settings, and we want to go into light mass settings right here. And we have the static lighting level scale, and setting it lower than 1 is going to increase your build times when you build your lighting, but it's going to make the quality of the lighting better. The lower the number, the better the lighting quality. So you can definitely leave this at 1 if you want a less intensive build, but I'm going to go ahead and put mine all the way down to 0.25. So now we have this indirect lighting smoothness down here, which is the smoothness factor for indirect lighting. And it's actually important that this number times this number equals 1. So whatever you change this to, change this one accordingly. So 0.25, I'm going to change this one to 4, so that now equals 1. We also have this number of indirect lighting bounces, which is how many times the light will bounce around in the world. And we want to move this from 3 to about 10, so we'll get a lot more bounces in the world, and it will do a better job of just overall lighting our scene. If you have a skylight, you could do the same thing for the number of skylighting bounces, but we don't have a skylight since it is just for the interior. Alright, so let's put the rest of these spotlights in here. I'm going to change to unlit first, just so it's a little easier. And if you just hold down Alt and drag, it'll duplicate our object, and you can just drag out another one. And I'm just going to create more spotlights for these right here. So, just positioning, put it a little down. Okay. And we have another right there. Alt and drag. Perfect. Alt and drag. I have one above the stairs here. Rotate that 90 degrees. And I think I'll just speed up the rest so you don't have to watch me do this for every single one. Alright, so I've now put a light under every single light except for the one in this back room, which I chose a broken one, so I did not add a light in there. But it is totally up to you when you create your own scene. And you may be wondering why there's this red X over some of the lights we have over here. And that's because static lights in Unreal Engine can only have so many other lights that overlap with it. It can't have, I believe, more than 4 static lights overlapping. So what we actually have to do is we have to change all these lights to movable, which does decrease the quality of the lighting just a bit, but it won't be too much of a difference. So I'm just going to select all my lights right here and just hit movable under mobility. And now they should all be good and working. Also going to put them all into the lighting folder. Now if we go back to lit mode, you can see we have a much more lit scene. It is pretty dark, but it's not impossible to see, and the flashlight definitely helps a lot. Checking the lights, making sure they all look good. I just realized there's no collision on this fence, so we can just walk right through it. And see, this one is funny. But other than that, it looks pretty good right now. In the world settings, I'm also going down to light mask settings, and I'm going to check use ambient occlusion, and then we are going to build our lighting. So on this little corner here, I'm going to change the lighting quality to medium. It's good to keep it at medium or preview when you're just working on the game. Production will take the longest, but it'll produce the highest quality. So you'll want to bake it at production before building your game. But I'm just going to put it at medium for now, and then I'm going to hit build lighting only. Now with these world settings, these light mask settings we added, it'll bake this into it, and it'll improve our lighting quality a bit. So now, after it's done, we can just ignore these. You might not notice too much of a difference, but we've improved the quality a bit with those light mask settings. All right, that's going to be it for this one. You're totally free to mess with any of those light mask settings as you wish, or just with the spotlight settings themselves. You can definitely, if you want, just increase the intensity to make it brighter or darker. You know, if I put them all at 8, it's a bit of a brighter scene. It's definitely a lot easier to see things, but the flashlight becomes kind of obsolete. So it's up to you how you want to do that. Anyway, I will see you in the next episode for post-processing. Alright guys, now it's time to add some post-processing effects, and in my opinion, this is where it gets a little more fun. Post-processing is kind of fun to mess around with once you get the hang of it. So we already added our post-process volume. We used it to balance out the exposure, and we already made it unbound, so it doesn't have to be within the confines of this box for it to work. So first off, I'm going to go down to rendering features, this tab right here, and we have a tab called motion blur. And motion blur, as you guys probably know, is how much it blurs out when we move our camera. So it's at a default of 0.5, and I can demonstrate by pressing play. When we kind of look left and right, things blur out just slightly. And if we put this to 0 and hit play, nothing blurs out at all. So it definitely feels choppier. Some people prefer it like that. And if we put it to 1, for example, everything gets really blurry when we move. A value I like is 0.7, and motion blur definitely is kind of a controversial thing among people who play games. So this is just for you to mess around with between the values of 0 and 1 and feel it and put in what you think feels right. 0.7 works just fine for me. So now let's go to where it says lens. And first thing we're going to mess with is bloom. Now bloom is used to kind of fringe out the edges of light to kind of give the effect of its brightness. And if we turn it way up, you can kind of see what it's doing. Of course, it is a low light scene. In some games, I like to turn it up more than the default, but Since this is a horror game and it is supposed to be dark, I usually leave this, I would leave this as is. But once again, totally up to you. Next we have chromatic aberration, because we already did exposure. And chromatic aberration is an effect to replicate refraction of light. So if we turn this all the way up, you can see it kind of separates the colors, which is kind of fun to play around with. Pretty nauseating if you were to just leave it like this at full strength. But I like to leave it just as a very subtle amount. So I will put it at 0.3. And it is almost completely, there's almost no difference, but just a little subtle thing that I like to add in. So next we have vignette. So if we go to image effects, vignette just adds darkness to the corners. It defaults at 0.4. If we were to take this down to 0, if you kind of look at the corners, you can see they brighten and darken as I change the scale. I'm going to turn it up a bit to 0.6, just to have that darkness on the edges. Grain, jitter, and intensity, you can choose if you want it to have a grainier look. If you don't, you can just leave these at 0. But I think I'll put the intensity up to something like 0.5. Or I'm sorry, the jitter up to 0.4, and then the intensity up to something like 0.5. And you can see if I change the intensity from 0 to 1, the grainy effect it has on our camera. So now we have a bit of grain, which is definitely a stylistic approach. 0.5 might actually be too much. Maybe I'll try something like 0.3. And the jitter down as well. I think I might have made it just a bit too much. So maybe 0.3 and 0.3. For depth of field, we're actually going to have a separate episode on that, so we're just going to skip it for now. Now if we go to film, we can change things such as the slope and toe, which just kind of changes brightness and darkness and things. So if we go to the slope and we turn this down, you can see it kind of gets, and we turn this down, it kind of lightens the highlights. So I'm going to turn this from 0.88, which is the default, to 0.6. The toe kind of darkens the shadows. I'm going to change this from 0.55 to 0.5, so just lighten it up just slightly. And then the shoulder can stay the same. So if I enable and disable the toe, you can see the difference right there. Same with the slope, which is a bit more of a difference. You can see it's a little easier to see in here now. You can definitely maybe not do it as much to help with the flashlight rule I was talking about when lighting the scene at all, but it's up to you. We also have other options like color grading, so you can change the white balance, the temperature if you want to make it darker or cooler. Not darker, warmer or cooler, sorry, but I'm not going to mess with that. Global color balance, so you can kind of give them tints, or oversaturate or undersaturate. It's a fairly black and white scene, so it's pretty hard to tell what's going on here because there's almost no color. But for the most part, I just wanted to clean some things up and make it just a bit more on theme for a horror game. So to show you the effects of the post-process volume on and off, I'm just going to toggle the unbound. So once I turn this back to bound, it'll only be in the effects of this square, but we'll be out, or this cube, but we'll be outside of it. So this is what it looks like without the post-process. Very just normal, clean look. Very exposure comes up way too high. Very dark blacks and very light highlights. Then we turn it back on, and we have this grainier, darker vignette, lighting a bit more balanced look here. And post-process volumes are very powerful, and there's more that goes into it. I just wanted to go over a few things to really spice up the look of your game. So that's going to be it for this episode, and I'll see you in the next one. So fog is a great way to add some depth and atmosphere to your scene. We're going to do this with what's called an exponential height fog. And if we just drag it in, you can already see the difference it makes when it's in and out. I'm going to put it in the rendering folder right there. I'm going to change the fog in scattering color to white instead of this very light blue we have here. You can kind of see the difference right there. And just to show you, I'm going to turn the density up to, oops. And just to kind of show you the effect it has, I'm going to change this fog density to something like 0.1. And you can see how good this could look for an exterior scene. Of course, this much fog doesn't make quite as much sense for an interior, so I'm going to put this at something like 0.04, which is still rather thick for an interior, but I really like the look that it gives. The fog also accentuates the grain, which we could turn down a bit too, but I think it's at a good level at the moment. So we can also turn up the start distance. Right now the fog starts right where we are. So if we turn this up, you can kind of see how it starts farther away from us. I'm going to make it start at something like 500, so where we directly stand, there's no fog in us, it's more in the distance. If this was an exterior scene, you'd probably want this a good amount higher, but it really depends how foggy you're trying to make your scene. So this was a very short episode on exponential height fog. There's not a lot you should do with it when it's an interior scene, but it definitely helps with the atmosphere. This is it with it off, and this is on. So I think it's a good addition. So let's add some dust to our scene for a better sense of atmosphere. It's just going to be a particle effect that just has dust particles floating around. Let's create a material. Let's go to our materials and let's create a new material. We'll call this M dust. You can open it up. And we want to add a particle sub UV node, which is very similar to a texture node. And the texture we want is going to be dust particle D. This comes with the starter content, so if you enabled starter content when we created the project, it should be there. We also want to get a particle color node. And we can multiply, hold down the M key and click the color by the RGB, and then hold down M again and the alpha by the alpha. The material type, we need it to be translucent, and shading model needs to be unlit. This multiply will go into the emissive color right here, and the alpha will go into the opacity. So now if we put this on a plane, you see we have these 4 different dust textures. So let's save that, and let's create a new folder called particles. You can open that up. We're going to create, right click, particle system. We're going to call it P dust. Okay, we have this default particle system right now. And we're just going to go through these things right here. So click on this required tab right here, and we have an option for the material. And instead of default particle, we're going to be using M dust, the one we just created. And you can see it's the exact same particle effect, except it's the plane with the 4 dust particles. Now in this list, right click and choose type data new GPU sprites. And we also want to right click and add a new sub UV sub image index. And this node right here is why we need this node to be particle sub UV instead of just a regular texture node, because now we can choose a number 0 through 3 to choose which one of these 4 dust particles we want to use. This won't work until we go to required, sub UV, right here, interpolation method as linear blend, and then sub images horizontal and vertical is 2 by 2. So now it changed it from all 4 to just one of them. Alright, so now let's go to spawn, And here at rate distribution, we're going to bump this up to 100. So it spawns about 100 rather than 20. And lifetime is going to be a minimum of 5 and a maximum of 10. So now they last quite a lot longer. Initial size right here, start size, we want a maximum of 4 and a minimum of 2. So now they are a lot smaller. Initial velocity, we want distribution here, we're gonna decrease it a bit, so 5, 5, 5, negative 5, negative 5, and negative 5. Initial location, we need to add that, so right click, location, initial location, just like that. We want the start locations to have all different points rather than just this center point. So we're going to do a max of 1,000, 1,000, and 1,000, and then a minimum of negative 1,000, negative 1,000, and 0. So it's kind of hard to tell with this black background, but now they're spawning over a 1,000 or 2,000 by 2,000 by 1,000 box. Now here up at bounds, just click on this little arrow and hit set fixed bounds, and let's go ahead and test it in the scene. So I'm going to save. I'm going to drag out this pdust, and now they're all highlighted so we can kind of see what's happening here. And I'm just trying to make it so it covers everything up. Let's see what happens if it looks in unlit mode. Alright, I turned off the exponential height fog real quick because it makes it a little easier to see where they are. And I'm just kind of trying to move it to where it's covering up our entire scene. Alright, so let's go ahead and hit play, see what it looks like. Oops, spawned on top right there. And you can see, if you look around, we got these dust particles just kind of spawning in, floating around, and spawning out after 5 to 10 seconds. There we go, and it looks good. One issue we have is that it's only spawning the first out of the 4 sprites. We want all 4, so let's go to mdust, not mdust, sorry, the pdust, the particle itself. And we want to duplicate this emitter 4 times, or 3 times, so go to emitter, duplicate, emitter, duplicate, oops. There we go. And emitter, duplicate. So now that we have all 4, we can go to the first one, go to sub-image index, change this distribution to a float constant, and I'm going to change this constant to 1, or no, to 0. And the second one, I'm going to do the same thing. Change this one to 1. The third one, sub-image index, float constant, 2. And this one, sub-image index, constant, and float, 3. Now we also have to decrease the spawn rate, because now they're all spawning a ton. We can see what that looks like in game. Yeah, it's definitely too many. It looks like it's snowing. But we should be getting all 4 different types. And it looks like we are. Yeah, those 2 definitely look different. Alright, but it's definitely spawning too much, so just go to spawn, change this from 100 to 25, and I'm going to do that for all of them. Okay, we hit save, we hit play, and I think that looks pretty good. Alright, so that's going to be it for the dust particles. I will see you in the next episode. So the reason I skipped over depth of field in the post-processing volume back on that episode is because while you could just go in there and set the depth of field how you like, I'm going to show you how to implement updating depth of field so it automatically focuses on what you're looking at and puts everything else out of focus. This is an aesthetic choice I see in some horror indie games. It can be a nice effect in the right settings, but other games you just want a regular constant focus like how it is at default. So let's go to our L1 character, which I have open right here, and I'm going to create a function called updateDOF for depth of field, and I'm going to create a line trace. So line trace by channel. The start is going to be the camera, get world location. The end will be the camera's forward vector multiplied by a certain amount. I'm going to make mine 300 and then add it on to the world location. And we're going to create an if branch from the return value. So we only want to continue this if we hit something. Let's break the out hit result. And we're going to create a local variable called local DOF for depth of field. It's going to be type float. And we're going to set it off the true path right here. And what we want to set it to is the location minus, not minus int, location vector minus vector, the world location of our camera. And we will get the length of this, so vector length, and that is going to be our depth of field. If we don't hit anything, which means we're too far away from something to focus on something, we're going to set the local depth of field to 0. Now we need to actually set it in our camera's post-process effects, so bring up the camera again, and we're going to set post-process settings right here. Just connect these two, and we're going to make it right here. And since there's so many, instead of just actually having them all listed here, we actually have to check which ones we want to affect. So we'll just search for focal distance under lens depth of field, and that'll create it as a pin. And the other one we want is depth blur radius under lens depth of field. So the focal distance is just going to be our local depth of field, where our depth blur radius will come from a select node. And we only want to make this an amount if we are focusing on something. And we will check that by seeing if our local depth of field is equal to 0. So if our local depth of field is equal to 0, it means we're not actively focusing on something, so we want to leave the depth blur radius to 0, not to blur anything out. But if it's false, what we do want to blur out, we're going to set to a value of 250. Alright, so I'm just going to add a return node, because that's good practice to get into. And we have our function all set up. And then in the event graph, we're going to create, if it's not already created, the event tick. It's not. And we're just going to throw in our update depth of field. So we can test this now. So our camera is now every tick shooting out a line trace 300 units ahead of us. And since it's probably not hitting anything right now, everything looks normal. But if we get up close to something, you can see in the back there, it gets slightly out of focus, which it previously wouldn't be. And if we look over there, it shifts to become in focus because we're, I don't think it's hitting the stairs, so everything just becomes in focus right there. And it happens rather smoothly, which is really nice. Can maybe, let's bring a trash can out in the center to kind of test this more. So if you look at the trash can, it's in focus while everything else behind is rather out of focus, but we look away and everything becomes in focus once more. It's a pretty nice effect, and it adds a lot of cinematic quality, which is nice. We can try to kind of exacerbate the effect by bumping up the amount of depth of blur. Kind of see what it looks like a little better. So yeah, so now it's way more blurry when we focus on this. And this could be the effect you want. You could maybe want to go a little extreme with it. I think both look good. This one definitely appears more cinematic, but it's also slightly choppier because it just snaps to it. And it could definitely be harmful in the end for your character because it's harder to see in the distance what is coming. But that could be part of your game design. It is up to you. Alright, this is going to be it for the updating depth of field. I will see you in the next episode. So the good thing about ambient sound is that it's simple, and we already have an audio file we can use from the sequencer assets that we migrated. So if we open that up and go into audio, and then ambient, we already have this ambient interior room tone and this slight buzz. So if we just listen to it real quick, it's just an ambient sound that we can play in the background. And so let's just take this cue, let's drag it out into the world, and essentially that's all we have to do. We now have a 2D sound that plays at the same volume no matter what point we are in the game. So if we hit play, we have now have an ambient sound. We can go all the way over here, still haven't fixed the collision on that, and we still hear it at the same volume, and we will no matter where we are in the world. But we can still go over a few of the options in the details panel right here. If is UI sound is checked, it means the audio will still play when the game is paused, which also plays in the editor. We never implemented an actual pause in the game, so this is obsolete to us. This doesn't account for things like opening the inventory. I left it off and it's still playing. That's because that's not a real pause effect. It's just us switching to UI mode. We can also mess with the volume or the pitch. I'm going to go ahead and turn the volume down to like 0.6 maybe. It's a little overbearing, I think. Now it sounds much more like an ambient noise in the background. And if you don't want your sound to be 2D and you would like it in a location in your world, you can check override attenuation right here. And this will create an area where your sound will be played. If you scroll all the way down to attenuation distance right here, you can adjust the radius and the fall off distance, which is the distance over as it gets quieter, as you get farther away, how quickly that happens. And you can even change the shape if you would like. No, I'll leave that as a sphere. So I'll just show you right now. So if we walk away, we are currently using the fall off distance, and it is getting quieter and quieter. It's a pretty large fall off distance at the moment, so we can see we have a second sphere right here, which is the fall off distance. So once you leave this second sphere is when it goes silent completely, and the distance from the first, if you're inside the first sphere, it'll be at max volume, and from the points of this sphere to the points of this one, the volume goes from 1 to 0. So now let's spawn out here. So we don't hear it at all because we're outside the second sphere. We walk inside. We can hear it very, very lightly, and as we get closer, the volume increases. Now we're hearing it at full volume. And we leave again, and it fades out. So that's if you want your volume to be 3D. But we're just going to use a 2D sound for us, so I'm going to change this to false, override attenuation, and it is once again a 2D sound. Alright, so now that we're done with a lot of the essentials of what we need to create for a horror game, I thought we could work on a few things that are just a bit more fun to recreate some popular and unique horror mechanics from well-known games, starting with the camera from Outlast. So essentially recreating the camera is mainly just about changing our post-processing effects, adding a HUD for the camera, and giving us the ability to zoom in and out. So we can start with the HUD first. So let's go into UMG. And actually, before we create a widget, we actually need to import textures, just something I created in Illustrator really quick, which will be available for download. So if we go into textures, I'm just going to hit import, find my location, and just import the two. I have this camera box and this camera record button. And we can go ahead and open these, and I'm just going to, compression settings can be user interface, and texture group can be UI. It's fine for that one, and do the same for this one here. User interface for compression settings, UI for texture group, and since these here are straight lines, I'm going to change the filter from default to nearest, and that'll give us much crisper lines. I don't want to do that for the camera record dot because it's smoothing out right here will look a little better. If you see it in nearest, it's too pixelated, so I'm just going to leave that on default. Okay, so I'm going to go back to content, UMG, and we're just going to create a new widget blueprint. I'm going to call this W camera. Open that up. And we just have to make this look like a camera. So maybe I'll add some text in the bottom left that says 1920 by 1080. And negative 120, and then maybe in the upper right we'll add a horizontal box with an image inside of it, and this image will be our record dot, and let's make the image size 36 by 36, and then we'll add some text next to it in the horizontal box that will just say rec for record. Maybe add a spacer in between those with a X size of 10 to add some space. Let's make that record text red. That's the shadow color. Okay, horizontal box, let's anchor it to the top right, negative 100, negative 200 maybe, 120, something like that. And let's make this size Y 36, so the circle is a perfect circle. We can also add the image of the camera box, which I'll just drag in the center. Camera box. We'll make the size 250 by 250. We will anchor it to the center. Alignment 0.5 by 0.5, and then we can position X and Y at 0 to make sure it's in the center. And let's make the opacity of this something like 0.6. Alright, so that looks pretty good for now. You can customize this as much as you want. We can also add a little animation for the record button to give it some life. So if we select the record button, I'm just going to rename it to record image. And then we hit animation, and we can just call this rec image flash. Go to the timeline, select rec image flash, and we need to add a track. And since we have record image selected, it'll pop up right here. So we'll choose that. And then we can choose what subtrack we want, and we want the render opacity as a track, because we're just going to have it fade in and fade out. So at 0, we'll have a render opacity of 1, so we can add a keyframe right there. We go to 0.75, we'll make this 0, and I think it should add keys automatically. And then we'll go to 1.5 and change it back to 1. But we're going to make the length of the overall animation 2 seconds. So add another keyframe right here at 2 seconds with the opacity of 1 so that it stays at full opacity for half a second. So let's check this out. Let's loop it by hitting this button right here and hitting play, and then we're going to deselect it, and we can just see it up there, and that looks pretty good. So let's go to the graph, and on event construct, which is the begin play essentially, we can just get this rec image flash animation. We can type play animation. Start time can be 0. Number of loops to play is also going to be 0, which means it'll play indefinitely. Play mode forward, playback speed, you can mess with if you want it to be faster or slower, and that is all good. Alright, so let's go back to our L1 character and the event graph, and essentially just what we want is to be able to pull out the camera when we hit a button, which we're going to assign to R. So let's go to Edit, Project Settings, Input, and we can add a new action mapping, and we will call this camera. And do we want on an R? Crouch button is left control. We can make it C, I guess, because I don't think anything else is using C, and that makes more sense. Thought we were using crouch for C for a minute, but we're not. Alright, yeah, we're gonna go with C. So we can just hit input camera. Now it should come up. And what we want to do is, first off, put the widget on our screen, but we're going to actually create the widget in our initialize function. So let's open up initialize. We can add a pin here, or actually, let's do it off then one where we already create the main HUD widget. So we'll create another widget. And the widget we want to create is wCamera. And we're going to promote this to a variable. And we'll call this camera widget ref. But we are not going to add to viewport because we don't want it on the viewport quite yet. So back to the event graph, input action camera. Right now we're just going to use a flip-flop, which just means it does A, and then when we press camera again, it does B, and it switches forever. But you can switch this out with a Boolean. Actually, let's just go ahead and create that Boolean. So is in camera as a Boolean. Default should be false, and then we'll just create this as a branch, and that's probably usually the way you're going to want to do it. So if you're not in the camera, we will set is in camera to true. We want to get the camera widget reference, add to viewport, get the main HUD reference, remove from parent, which will take it away from the viewport. Actually, instead of removing it, let's set it to hidden. So set visibility, and let's do hidden. And then let's reverse it for the true. So let's copy and paste. Is in camera will be false right here. Camera widget ref, instead of adding to the viewport, we will remove from parent. And then we will set the main HUD ref visibility to non-hit testable self only. So we can actually test that out now. When we hit C, it should switch our main HUD widget right here to our camera widget. Alright, we're now in the camera widget. We've got our animation playing in the top right. We've got our box in the center, and so far that's the only thing that changes. We'll hit C again, and it switches back. Perfect, that works really well. Alright, so now let's add our zoom functionality. So we'll do this with two inputs. So edit product settings, input, and we're gonna add two. This one will be zoom in, and this one will be zoom out, and zoom in will be mapped to the mouse wheel up, and zoom out will be mouse wheel down. And an L1 character right beneath the camera. We'll add input zoom in and input zoom out. And we're just going to be changing the field of view when we zoom in and out. So we need two variables for the minimum and the maximum field of views. So I'm going to create the first one called min FOV, and it's of type float. And the next one will be max FOV. Let's compile and set these. The min is going to be 30 degrees, and the max is going to be whatever our default field of view is in our character. So if we go to initialize, and we're just going to put it in here, off of then 3, pull these out so I have room. I'm just going to set the maximum field of view to our camera and get field of view. Because we don't want the camera to get a wider view than our human eyes. So if you ever want to change the camera's FOV, you don't have to worry about changing this variable as well. All right, so let's do zoom in first. We just have to make sure we are in our camera to zoom in. And if we are, we can just get our camera, set field of view, and we just want to get our field of view, and we want to add 5 to it. You can change this, you can make this into a variable if you'd like. This is just how fast and you'll zoom in, but 5 is something that works for me. And then we want to clamp it so it doesn't go above or below the minimum and maximum. So max is max FOV and min is min FOV. And we actually have to make this 5 -5 for subtracting, not adding. -5. So let's copy and paste this to the zoom out. And instead of adding -5, we're going to add +5. All right, so let's test that out before we continue. So let's hit play. If I move the scroll wheel, nothing happens because we're not in our camera. I'm going to pull out our camera with C, and now when I scroll up, we zoom in, and we can't zoom in more than 30 degrees. And if I zoom out, we zoom out, and we can't zoom out farther than our normal view. So we can now zoom in and zoom out, which is great. But you'll notice if I zoom all the way in and then I leave my camera, we are stuck at a 30-degree view, and we don't want that. So in L1 character, after leaving our camera off this true path here, we want to set the camera's field of view back to our default. So set field of view, and the field of view we want is going to be our max FOV. And lastly, we just need to make it actually look like a night vision camera, because we got everything else so far. We can see that it resets our field of view when we go back, but we want to make sure it looks like it's night vision, and we'll do this with post-process settings. So we want to add another post-process volume into the world. So post-process volume, drag this out. It doesn't matter where it is. And just to be able to test what this one looks like, I'm gonna take our first post-process volume and I'm gonna turn off unbound so everything gets reset. Then this post-process volume will take priority, because for this one we do want to check unbound. So now we're seeing what's happening in this post-process volume 2, which I'm going to rename to post-process volume Outlast camera, and I'm going to put that in the rendering folder. So first off is the exposure, like always, except instead of setting it to 1 and 1, I'm going to set it to 0.5 and 0.5, so it's a bit brighter than our regular view, because it's a night vision camera, so it should be able to see a little better. And before we change the other things, let's go ahead and match the first post-process volume things that we are not going to change, such as the motion blur. So let's see, I set the motion blur to this one at 0.7. So on this one, we also want it on 0.7. The chromatic aberration, I'm not going to change. So this one, we set it. Oh, did we not set it in this one? I thought we did. Chromatic oh, we did. Intensity 0.3, intensity 0.3. And now we should give this a green tint. So if we go to color grading and miscellaneous, right here, MISC, we have scene color tint. We can check that and we can tint the scene. So we're just gonna make it fairly green. We want to up the bloom, or just so it fringes the light a bit more. I want to add more of a vignette. So that is right here, vignette intensity. I'm going to change this to 0.8. And I'm going to up the grain a lot. So the intensity I'm going to put at 0.7. And the jitter at 0.6. Okay, so we can hit play, and this is kind of the view we'll be getting when we're in the camera. I'll switch to the camera mode, so this is kind of what it looks like. So we just have to make it so it switches back and forth when we come in and out of our camera. If you want, you can also go to the slope and turn this down a bit just to, brighten up the scene. So maybe like a 0.5. Because it is a night vision camera, so you want to be able to see things a bit easier. I think that definitely helps with the Outlast look of it all. Alright, so let's set this first post-process volume back to unbound. And let's set this one as disabled, so just disable the volume. So we're just back on our regular post-process volume at the moment. Back in the L1 character, let's create an event dispatcher here called toggle post process. Now let's give it an input right here called camera bool, and it will be a boolean. Event dispatchers kind of work like blueprint interfaces, where they can be called from other blueprints, but dispatchers work more specifically to one blueprint you're trying to reference, rather than kind of a global can be assigned to anything, if that makes sense. So I'll just show you on the camera. When we press it, we want to call it after pulling out our camera and setting those settings. So we'll drag this out and we'll hit call. And when we call it here, we want to check camera bool because we want to change it to the camera post-process settings. And then we'll call it again when we put away the camera, and this time camera bool will be false to go back to the regular settings. And now let's go to the level blueprints, open level blueprint. And in the begin play, we have to cast to the L1 character. So let's get player character. Cast to L1 character. And from here, we can assign, I'm going to close the widget, we can assign this dispatcher. So we will call toggle post process, and we have these options, and we're going to hit assign toggle post process. So this creates a node and a custom event. So we're just going to call this toggle post process event. So this event here, we have to leave this connected. Essentially, every time that this is called, this event will fire. And we do it from the level blueprint so we can reference these post-process volumes. So we have the default one, which is our global, and just have it selected. Right click and create a reference to post-process volume. And let's do the same with the camera post-process volume. Right click, create reference. And we just have to set these enabled and disabled accordingly. So we will set enabled. And if the camera bool is true, that means we want to use the camera post-process. So we're just going to put a not boolean into here. So if camera bool is false, this will be true. And if it's true, it'll be false. And we'll do the same with this one, set enabled. And we'll just plug in camera bool directly without the not boolean. So now it'll switch between the two depending on whether this camera bool is checked or not. So we press input action camera, we open our camera, we add the widget, and then we call toggle post process with camera bool checked, which disables our post process volume and enables the camera one, and it does the opposite when we close the camera. So we can test this out. So we have our normal post process volume going on here, and when we hit C, it should call the event dispatcher, go to the level blueprint, and switch the enabled between the two volumes. And it does. Now when we open our camera, we have our Outlast camera post-process volume. And when we close it, the same thing happens. Alright, so that seems to work perfectly, and it looks really good. The result is amazing. Alright, so that'll be it for this episode. I will see you in the next one. The Resident Evil camera system is actually relatively easy, and just for clarification, we're talking about the original Resident Evil with preset cameras based around the level design that follow the character rather than a traditional third person or more recently first person. But we are doing the original, and it is relatively easy to do. Now we're actually going to create a new level for this, just not to mess with our horror level that we worked on. So let's go to content, maps, level, or instead of just creating a level like that, let's go ahead and hit file, new level, and let's create default so it comes with some lighting things like this. Hit save, go to your maps folder, and I'm going to call this Resident Evil level. And like always, first things first, let's get a post process in there. Is there already one? No, there's not. Post process volume. Set it to unbound. And fix the exposure to be 1 and 1. Alright. We also want to go to the world settings and select our game mode override to our L1 game mode so that it uses our character and our HUD and our controller and all that. So when we hit play now, we are playing as our normal character. Sorry for the noise outside, if that's audible. Not sure if that's going away anytime soon. Okay, so I'm going to construct a small level just really quick. Nothing like the last one, but just going to make a quick U shape here, as if it's some kind of corridor. Alright, so that'll be good enough for me. We just got a quick corridor, just like this, to test out a few different angles. Now since this is from a different perspective where we will actually end up seeing our mesh, we need a mesh for our character, otherwise they'll be completely invisible. So go to L1 character, viewport, and we have this mesh that's inherited, so it's already there. And let's just add a capsule. Oh, we can't add a capsule because this is a skeletal mesh. So instead of this mesh, we're going to add a component of static mesh. And right here we will get a capsule. Let's see. I don't like either of those, but you use what you can. So let's bring this down and then scale it up, and then I guess widen it a bit. All right, that's good enough. And we just want to make sure the camera, our first-person camera can't see this mesh. So click on the mesh, we go to owner, and we check owner no see. So now the camera will not render the capsule, just this camera. All right, so let's go to actors, and essentially what we need to do is it's just going to be trigger boxes linked to cameras, and when you enter the trigger box, it switches to that camera, and then the camera follows you. So let's go to Blueprint, Actors, and we're just going to create a new folder called RE for Resident Evil. And I'm going to make a new actor, so Blueprint class, actor, and I'm going to call it BP RE camera. Open it up. We will add a camera, and then in the graph on our tick here, we just need to make it always look at the character. And luckily, Unreal Engine has a node built in for that, so we don't have to do all the math. And it's called find look at rotation. And we have the start, which is our camera's position, so we can just get actor location. It's wrong node, get actor location, just because the camera is in the center. And the target can be our get player character, and then just get actor location. And that is the target. And then we'll just get the camera, set world rotation, and the find look at rotation will be our new rotation. We need another actor, Blueprint class, actor, and this will be called BP RE trigger box. These will be the boxes that go with the cameras. So we just have to add a box collision, make a variable for the extent, so we'll call it box extent. This is just essentially the size of the box. It'll be a vector, and we want it editable, so we can edit it in here. And then in the construction script, we will just get the box, set extent, and the extent will be our box extent right here. And we can make the default box extent 32 by 32 by 32. And since this is in the construction script, we can change it in real time. We're changing this variable right here, and it is updating the box extent. Let's add another variable called BP RE camera, and this is of type BP RE camera, as you might have guessed. And let's select the box, get a begin overlap node right here. On the other actor, what we want to check is overlapping is our character. We will cast to L1 character. So only if our character overlaps it. We will get the player controller, and we just need to transfer our character's view to the camera's view. So we'll get player controller, we'll use a node called set view target with blend. So the new view target will be the RE camera. Blend time is nice because we can change it from 0 to an actual blend time, so it'll interpolate from our camera to the other camera. And once we get this set up, I'll actually show you an example of that. But if you want it to work like the actual RE system, you'd leave this at 0, so it just snaps from one to the other in a single frame. All right, so let's add Oh, before we continue, make sure RE camera is editable. We need to be able to reference it. And so let's, in the world, let's add a trigger box. Go to details, and we can up the extent. Something like this. Okay, so when we overlap this, we need a camera for the to follow the player. So just drag one out into the world, set it up where you'd like. I'm going to put it in the corner here. Maybe like this, and then up here, and then I will angle this down about 20 degrees. Okay. Now we take the box and we want to say, okay, what camera will this box reference? So when you enter this box, what camera will we use? Right now we only have one option, so it'll be this one. So you can take the eyedropper tool with the box selected, where it says BPRE camera, and choose the camera you want. Now it says BPRE camera. You can also do the drop down because there's only one in the world right now. But let's actually create like 2 more for now. So let me select the box. I'm gonna pull it over here. This one I think, oops, I will make wider to cover up this whole section. And we will add in another camera. I think I'll put this one right here, for example. Rotate it down 20 degrees. See how that looks. And then lastly, we'll add a 3rd box right here. And we'll have some kind of fancy hero shot with the camera on the ground looking up at us. So let's take the 2nd box and we're like, okay, what camera do we want to use? Right now, since we duplicated it, it's still using this camera, so we gotta change it to this one. And for this box, we want to use this camera. Alright, so let's go ahead and test that out. So we have our first box straight ahead from us, and when we overlap, it should use the camera in the upper right over there, both of which we can't see, but hopefully it should work when we cross the box, which it does. And now when we move, we have our camera following us when we play. And when we go to this one, it should switch. Alright, it's looking good, looking good. And this one, we have our hero shot. Perfect. Actually, not quite perfect because there's a few things that aren't great, such as the camera shakes. They don't look that great on these kind of cameras when they should look a lot smoother. And it is actually pretty hard to walk around, which you can't see, but it's still having us walk around based on our player right here's rotation. So when I hit the down button, I feel like the character should walk towards the camera because that's what feels natural, but it'll actually walk that way. So it gets kind of confusing, so we got to fix that. So a little trick we're going to use to do that is inside the trigger box. Once we overlap, we're going to get the player controller again, so I'm just going to copy and paste this. And we are going to set the control rotation to our BP Resident Evil camera. So we'll get the rotation from that. Get actor rotation. We're going to break it because we only want the Z value. And we'll make a rotator from there. And we're just taking the Z value from that actor rotation. So now when we play, when we enter a box, it should switch. So now when I hold down the buttons that feel like they should bring you towards the camera, they actually do. Same should happen when we switch. Yeah, that feels natural. Alright, and lastly, if you were to just want to remove the camera shakes, then I would just go to the event graph, find our movement, and I would just remove the head bob functions right here, and then it would be just as simple as that. So no more camera shakes, smooth movements. Now, of course, that's just the base of it. You know, if you want to continue with this type of movement, you could remove the HUD, etc. I just wanted to make a quick, fun episode on the Resident Evil cameras. By the next episode, I'm going to put these head bobs back in. I'm going to actually remove this capsule, even though it doesn't matter too much in the long run, because I'm not going to be coming back to this. Just to set everything back to normal. Just wanted to make a quick episode on that, just for fun. So let's go to maps, and I'm going to go back to horror level, and we can get back to our actual game here. Alright, I will catch you in the next episode. A good horror mechanic you've seen repeated through the years are security cameras, inspired from the original Five Nights at Freddy's. And they've been done plenty of ways since then, and while of course it is integral that you come up with something unique for your own game, I'm still gonna, just for fun, show you how this is achieved. And luckily, it's also relatively simple and done in a pretty similar way as the Resident Evil one we did. So let's go into Blueprints, Actors, and I'm going to make a new folder called Security Cameras. And we need 2 actors, and one of them is going to be the camera, and we can put as many security cameras as we want throughout our map. And the other will be the camera controller, which, for example, in Five Nights at Freddy's is that laptop/computer you have in front of you that you can interact with. So let's make the controller first. So right-click, Blueprint Class, Actor. We're going to call it BP Camera Controller. And make another actor, BP Security Camera. So let's actually make the security camera first. It might be easier. So let's add a camera to our actor, and let's mess with the camera's post-processing. Since we're actually using a separate camera this time, we don't have to do the same technique we did for the handheld camera, since this is the same camera that we use. We don't switch cameras. We had to find this workaround, but since this is a completely separate camera, we can actually go into its post-process settings down here and mess with these. So since we've gone over it twice now, we can just go over this quicker and just switch it up. So I'm going to get into lens, exposure, and the min brightness and max brightness. I'm going to be 0.8 and 0.8, just so it's slightly lighter than our default. And then in image effects, I'm going to turn the vignette up to 0.6, and the grain jitter and intensity I'm going to also put at 0.6 for both of them. And then in color grading, global saturation, I'm going to change the saturation to 0, so it is completely black and white. Even though in this level you wouldn't be able to tell too much of a difference, because most of these assets are pretty grayscale anyway. But I guess for reference we can throw a cone in and try to find some colorful material like that. So okay, yeah, so we'll be able to take a look to make sure that works. And that's all we'll do for the security camera right now. We can just put 2 cameras into the world, at the moment. So maybe something like this, a bit higher, and then rotate it down just slightly. And you can already see that this red cone has turned black and white on the preview right here. So we know that that post-processing is working, which is great. All right, and let's add maybe a camera for the stairs. Can maybe put one up here. I don't know, you just kind of get to have fun with this part. And then maybe we'll have one in the room that we can't reach over here. Like that. Okay, yeah, these look good. I'm gonna add one more just for this room in total. Okay, now I'm done, I promise. So let's make this camera controller. So we're just going to add a box right now, or a cube, I should say. And you can replace this with any kind of like a computer monitor or anything like that. Just gonna pull it out into the world to make sure I got the sizing right. I guess that's fine. Maybe a bit bigger. Like, well, yeah. All right, that's good. And this is just what we will interact with to get into the security cameras. And in order to interact with it, if you remember, we need to implement our interface. So go to class settings, implemented interfaces, add BPI interaction right here. And now when if we implement this function and we press E on it, then this will be called. We can test this by printing a string, just saying go into security cameras. I know I spelled security, I will not be fixing it. So now if we hit E on it, go into security cameras, great. Okay, so let's delete that. And we need to create a bool called is viewing cameras. And we'll just create an if statement off this interact right here. And if we are not viewing cameras, then we want to go in. So we will set is viewing cameras to true. Then we will get the player controller and we will disable input. This goes into the player controller, not the target. The target will be our player character. So once we are in the cameras, none of our input will work. So we can't like open the inventory and do all that. None of the buttons will work that are set in our character. Get player controller. We want to set ignore look input so that and make that true. So you cannot look around while viewing the cameras. I also want to get rid of the HUD, so we will have to get player character, cast to L1 character. We can right click and make that pure because we don't need the execution. And then we will get the main HUD ref and set the visibility to hidden. Now we want to enable input for this actor right here. So it just pays attention to this actor's input. So we will get the player controller and enable input. This will come to the player controller and the target will be self. Now let's make a custom event for undoing all of this once we leave. Call it leave camera controller. We will set is viewing cameras to false. We will disable the input for this actor here. So get player controller, disable input, target self. We want to reset ignore look input, so we will once again be able to look around. We will grab all this and set the visibility of our main HUD back to non-hit testable self only. And then lastly, we will enable input for our player character. So get player character and enable input as that target. Just to be safe, we can call this custom event from the true here and just leave it like that. Now let's create an input. So let's just do input spacebar, and let's just print a string for now. And we will say pressed spacebar. All right, so let's test this out. So when we hit play, everything's normal. Nothing happens when we jump or press the spacebar other than we jump. But when we interact with our camera controller, we can no longer move around. The main HUD disappears, and now when we hit spacebar, it switches over to our print string. Press spacebar. So what we want to do is when we hit spacebar, we want to cycle through our cameras, but we don't. This actor BB camera controller isn't aware of all of the cameras, the security cameras that exist in this world. So what we have to do is create a begin play, and we are going to get all actors of class, and the actors we're going to select is our security cameras. Now, out of the out actors, we want to promote this to a variable, and we're going to call this security cameras. So in the begin play, we don't have to create our own array and then add them in manually. It'll automatically detect every security camera in the level, which is great. So let's add a function called view through camera, and we need to create a variable called current camera index, and this will be an integer. So this will be the number of the camera we're on. I think we have 4 cameras in the world, so it'll be a number 0 through 3. And this will kind of keep track of which camera we're on, so we know which how to get to the next one. So we will get player character and set view target. Sorry, not get player character. We will get player controller and set view target with blend. And the player controller is the target, and the new view target is going to be the security camera at our current camera index. So we'll get a security camera, we will get a copy, and the index we want is the current camera index, which defaults at 0, and we will put that into the new view target. I'm also just now realizing that when we were working on Resident Evil, I said that I would explain, or I would showcase the blend time, and I just realized I forgot to do that, so I'll do it in this episode right here, just in a minute. After we set the view target, I'll just add a return node, because that's all we have to do at the moment. So now in the event graph, when we interact with our controller, at the end of all this, I want to call view through camera. So we will view through the first camera in the scene, which I believe is this one right here that looks at the cone. So now when we interact, it switches to the camera. It's in black and white, and we still have our movement and HUD disabled, which is great. And now I'll showcase the blend time, camera controller, by going to view through camera. So blend time 0, I think makes more sense for this type of thing, but if you want to see, if I put a blend time to 1 second, it'll blend between the current view and the new view, which is that camera up there. So if I hit E, it moves like this. Now the post-processing will still snap from one to the other, but it is still a pretty cool effect. But I'm going to change that back to 0. Now we want to be able to cycle through the cameras because it only ever shows us through the first one. So we're going to use the spacebar for that. So get rid of the print string, get the current camera index, and we want to set the camera index to that +1. And then after we add 1, we will just call viewThroughCamera again, which takes the input right here. So it should switch to the next one. We can test that out. So let's hit E. We look through the camera with the index of 0. We hit spacebar, it adds 1. We're looking through the camera with the index of 1. We hit spacebar, it adds 1. We're looking at the next one. Hit spacebar, we're looking at the next one. If we hit spacebar again, we have an error because there is no camera under that index. So it just gave us whatever that weird view was right there. So we need to cycle it back to 0 once we get to the maximum. So we will do this with a select node. So if this number, if the current camera index +1 is greater than the amount of security cameras, we want to reset it to 0. So we get the security cameras, and then we get the length, which is the amount, and we want to subtract 1 from this number, because the length starts at 1 when the index starts at 0. So if we want them to match up, we have to subtract 1 first. So if this amount is greater, then we want to set the index back to 0. But if it's not, we want to get the current camera index +1. So now, when we hit play, interact, I press spacebar, we go to number 1, because the first one was number 0. Number 2, number 3, hit spacebar again, we go back to number 0. So 0, 1, 2, 3. And we can cycle through them forever. Alright, so now we want to obviously be able to get back to our player once we're done with that. So in camera controller, at the end of leave camera controller, we have to get the player controller, set view target with blend. The new view target is our player character. Blend time is 0. And we just need to create a button to actually leave. So I'll use input return, which I believe is the escape button and the backspace button. And then I'm also going to use input action, which is our E key. So we press E to get in, we press E to get out. So I'll use both of these to call, what's it called? Leave camera controller. Alright, so now if we hit play, we go in and we hit E, we are back and everything is back to normal. We go in, we hit backspace, everything works. We can't hit escape because that'll just close our game, which is why I created backspace to also work with it. It should also work no matter what camera we're in. Yep. Alright, so that all works. And that is essentially the core of how it works. You can do all types of things, such as maybe going into the security cameras and say you want them to kind of, rotate a bit. You could easily do that with a timeline in the begin play, just like that, and just create. We've created so many timelines, you should be able to figure that one out for yourself. Just, have it affect the rotation of the camera on the Z-axis. Other things is you could always have it reset to 0 when you go back in. For example, if we switch to number 3 here and go out and then go back in, it's still on number 3, but you could always have it set back to 0 by going into the camera controller, and then on the leave camera controller, right before you set the view target with blend, you would just have to set the current camera index back to 0, so it just resets every time you leave. It would be as simple as that. So we hit E, we come out, we hit E again, seems like somehow the one up here got reset to the 0 itself, which is fine. But you can see that if this is the default one and we switch to the stairs one, we leave and we come back in, it goes back to the default one. Alright, so that's going to be it for this episode. I will see you in the next one. Alright, so let's start creating some artificial intelligence for our game. We're going to start out a little simple with just an AI which head follows you. So we're going to be messing with the bones of our mannequin. And this is a really fun trick because it's useful to put on pretty much any AI that you need to be looking at you. So let's get right into it. Let's make a new folder called AI. And I'm going to make a subfolder just called head follow AI because we're just going to be making this its own thing for now. So we need a new character. So let's right click, blueprint class, character. And we'll just call this head follow, or let's make it a AI head follow. There we go. And we can open it up, and we're going to add our mannequin as the mesh. So mesh inherited right here. Just choose the SK mannequin. We're going to position him correctly by giving him a -90 on the Z-axis, and then rotating him 90 degrees, or sorry, -90 degrees on the Z-axis as well. Now he needs an animation blueprint, so he knows how to animate. And we can set it right here, but we're going to make our own. So let's just right click, go to animation, and then animation blueprint. Then we can choose the UE4 mannequin skeleton, because this is what this is the skeleton we need to map it to, and we'll just call it ABP head follow. So it's going to be really simple at first. We're just going to take the idle animation on the lower right here under Asset Browser, and we're going to plug it into the result. Once we compile, it'll always play the idle animation no matter what. We can add them into the world just by dragging our character out, and we need to assign the animation blueprint. So go into the character, click on mesh, and then anim class. We just want to choose ABP head follow. So now he's in the world, and he will just stand there in an idle state forever. Alright, so let's go back into the blueprint, and let's mess with this setting so that his head follows you. We want to get what's called a transform modify node, and right here we can mess with the transform of a bone. So we need to select a bone to modify. So if we select the node, and then up here at the top we have the bone to modify, and we want to modify the neck. Specifically, if we can find it, the neck 01, because that's what we want rotating towards our player. Now we don't need to change the translation or the scale. So on here we have translation, rotation, scale right here. And we can just uncheck the exposed on translation and scale since we only need to mess with rotation. And we don't need this alpha as well, which is the strength. We're always going to have it at 1, so we can also uncheck the alpha if you'd like. So now it's just rotation and component pose. We can also plug this in. It's going to create a local to component node in between, and it'll do the opposite when we plug it into a result. So we should now be able to modify our neck bone. We're getting a warning right here because it says no components to modify selected, and that's because rotation mode is set to ignore right here, so we'll fix that now. And what we want is add to existing, which takes the current rotation and adds our input on top of it. If we select replace existing, our input would be the exact rotation it wants. Now if we compile, the error should go away, and if we can actually show you right now, if we just mess with the values and we look at our character here, his next now changes. Now I think we're killing him here, so let's reset this back to 0. Oh, well, now he's definitely dead. Let's promote this to a variable. So right click on the rotation, promote to variable, and we will call this head rotation. Oh, spelled that wrong. So let's go to the event graph and update this in the update animation node, which usually comes by default. And we are going to use, once again, this handy little node called find look at rotation, which will do all the math for us to get 2 points and find the angle between them. So for the start, where the AI is, we can just get this try get pawn owner node, pull off and get actor location, and put that into the start. For the target, we can get player character, get actor, not location, or not rotation, we do want location, sorry about that, and put that into the target. And we just want this return value to be set to the head rotation. And let's test out what that looks like right now. So if we hit play, our character's head follows us no matter where we go. It's always looking at us. So right out of the box, that works pretty well. Of course, it can do this, which is quite unnatural. But if you want your character to do that, then it's perfectly fine. We did get one error, access none, trying to read property, get player character. So let's figure out what's causing that problem. But before we do, I forgot to demonstrate one thing. If we crouch or jump, you can see he rotates his head on the wrong axis. Not the one he's supposed to be doing. So we're actually going to fix that first. I believe the reason we are getting the error is because the update animation manages to fire one off before it realizes who the player character is. So we just want to make sure the player character is valid. So get player character, go get is valid. We want to get the macro right here. And we only want to continue if the player is valid. So let's see if that fixes our first issue. So we just load into the world, we leave, and we get no more error. Perfect. Next we'll work on the his head rotating correctly when we move vertically. So to fix that, we will get this find look at rotation, and we're going to break it. Break rotator, and we will make a rotator from the head rotation. Make rotator. The Z will go into the Z. And before I continue, if you are having an issue where the head is offset by 90 degrees, which I've seen happen before, I'm not quite positive when it does happen and when it doesn't. It just seems to happen sometimes. Right here, you can add a float plus float, and then add -90 or +90, whatever you want. I'll show you right now. With that added, you can see it still follows us, but it's offset by 90. This might happen to some people by default, so just add this node in to correct it. But for us, it is already working, so we're just going to go Z to Z. But since the X and the Y are switched, we need to get the Y and put it into the X, and then the X and put it into the Y. So now, if we hit play, and we go and we jump, you can see he looks down when we jump, and he looks up when we crouch. So we almost have it perfectly, it's just inverted. So we will just take this Y value, and we need to multiply it, float times float, by -1, and put that value into the X. and that should invert it for us. We hit play, we hit jump, and he looks up at us, and we crouch, he looks down at us. So now his head perfectly follows us no matter where we are. So this looks really great and really creepy, but what if we don't want his head to turn past a human limit? I don't think this here should be possible, so let's add some limits. And we'll do this by adding clamps. So if we go into our blueprint and we have this Z to Z, what we're going to do is add a clamp angle. So clamp angle right here, and put the return value into the Z. If you had to add the plus 90 or minus 90, do this after the plus 90 or minus 90, so it would look something like that. And for the min angle degrees, I'm going to make it negative 45 and the max angle 45. So we can test it again. Now if we hit play, and he looks at us, and once we go past 45 degrees, he won't turn his head anymore until we get to the other side, which will look 45 degrees this way. So it looks good, but lastly, we want him to go back to looking forward if he goes past his limit, and we want him to smoothly move his head towards normal instead of snapping there, because if you'll notice, when we go to the other side, his head will just snap to the right or the left, and we want him to actually turn his head over time. So we just need to add a new boolean in the blueprint, and it will be called canSeePlayer. So after we set the head rotation, we just need an if statement right here, and we just need to make sure his head can turn far enough. So we will get this z value right here, and we just need to check if his head is able to rotate and look at us. So we will get the head rotation and split it, and we can get the z. And we're just going to ask if it is greater than negative 45 or less than 45. So we'll add an OR node. Oh, I'm sorry, I did this backwards. So if it is greater than 45 or less than negative 45, then we cannot see the player. So if that is true, canSeePlayer is set to false. So if it's outside these values. If it is false though, we can see the player because it's inside those values. So before we set the head rotation, we only want to update it to this find lookout rotation if we can see the player. So off of is valid, in between the is valid and the set head rotation, we just want to make sure we can see the player. And if we can, we will continue normally. If it's false, we want to set the head rotation to 0 on all axes. And then we want to make sure to plug this into this if statement so it can continue to update whether we can see the player or not. So we can test that now. And if we hit play, if we go out of his view, he should snap back to 0. And he doesn't seem to. So let me figure out why. Okay, so I see the problem. We're not supposed to use the actual head rotation since this won't ever go above or below these values since we clamp it. So instead of the head rotation variable, we need to take it from the z of the find lookout rotation. So let's move these over a bit, and then if I control grab these two, I can move them to a different node, and I'll move it to the z of the break rotator of the find lookout rotation. And then we can just delete this variable right here. Now if we compile and play, it should work. As you can see, once we leave the 45-degree limit, his head just snaps back to 0. But we want him to do this over time, so we need to make it interpolate. What we should also probably do is make these into variables. So I'm just gonna right click, do max head turn, and min head turn. And then just plug the min head turn or max head turn into here and min head turn into here. So to make it more natural, for him to interpolate it back to 0 instead of just setting it back to 0, instead of a set head rotation, we need to use an R interp2. So off false, I'm gonna just search for R interp. So I'm just gonna right click and search for R interp2 and get this node right here and plug the return value into the head rotation. So the current is whatever our head rotation currently is, and our target we don't have to change because our target is 0, 0, 0. Delta time, we can just grab from the delta time X here in event blueprint update animation. And the interp speed is how fast we want him to turn his head back to normal. I'm just gonna make the speed 5 as a default, and we can test it out once again. Let's hit play, and if we go into his vision, he snaps his head towards us, we move out, and he moves his head back over time instead of snapping. But he still snaps his head when we come into it. Okay, so let's go back into our blueprint, and here we set our head rotation to this math here from the find lookout rotation, and we're going to need another R-interp2 node. So the current will be our current head rotation. Our target is going to be this find lookout rotation math that we did. Delta time will be the delta time from the blueprint update animation. And the speed is actually going to come from a select node. We can't be constantly using an R-interp2 node if it's always trying to set our new lookout rotation, because there will always be a constant delay. So we only need to interpolate it if we're going from a head rotation of 0 when we can't see the player to seeing the player. If it's going from seeing the player to seeing the player to seeing the player every single frame and interpolating every single frame, it's going to have a constant delay, and that's going to look really bad. So the interp speed will come from a select node. And for the index, we're going to use a new Boolean called interp towards player. Plug that in. If it's true, then we want to set our interp speed to 5, which is the same I set for the other one. And if it's false, we'll set it to 0. So it's still technically using the R-interp2 node, but the speed is set to 0, so it'll do it instantaneously instead of actually interpolating over time, so it'll look normal. So after we set the can see player to false up here, we want to set our interp towards player to true, so that we know to interpolate next time we do see him instead of just snapping with this select node. After we set the can see player to true again, we're going to add a delay of 1 second and then set the interp towards player back to false. We need the 1 second delay so that it can finish its interpolation before setting this interpolation back to false. So we don't want it to start doing the interpolation, have it turn to false, and snap. So we need to wait just a second. So let's test that out now. So when we go into view, he interpolates his head towards us, and we come out of view, he looks away. And when we're going, when we're staying in view but moving his value, the interp speed is set to 0, so there's no delay, which works perfectly. Alright, so now he very naturally moves his head to always be looking at us within its limits. And it looks really great. This is something that you can use on any one of your AI, since head following is very common within AI. So that'll be it for this episode, and I will see you in the next one.